Hello? Hello? I think... Hello? I think better. Yes, okay.
A very good morning to one and all present here. I, Shakti Shri, on behalf of the National Institute of Technology, Rourkela, welcome all the participants for the fourth day of this GIAN course program titled Sustainable Approaches in Post-Harvest Handling and Value Addition of Fresh Produce. Today, we begin the lecture by a session by Dr. Pankaj B titled Irradiation Techniques for Fresh Produce Quality and Safety. Over to you, sir.
Okay, thank you. Good morning and welcome again. So we start today the session on irradiation techniques. Probably when we start with the non-thermal techniques, there is one technique that we discuss about irradiation. So that may be complete outline, particularly for today's session. We start with the starting from the how the worldwide trend for the irradiated food and what is the accessibility from the people, right, country to country, and when we're looking for the doses, is there any recommendation or it is accepted that doses for everywhere, and then also looking from the concerns, because still you may aware this technology is there for irradiation, but you cannot find like other non-thermal technology. It's quite popular in terms, it's not about the technology popularity, but using irradiated material is not, because they have some concern, because they need to take the permission from authorized bodies to use that one. Okay, so we're starting again, particularly food safety, food quality, that is the main concern. And nowadays, even whenever we talk about safety, is for the people health, the people are more concerned about their health. Even not only the developed world where the trend is emerging one, even developing country also looking for that one. Okay, whatever we consume, or whatever the product we are consuming now, they are safe to consume. Okay, if something is going to be that is permissible above the permissible limit, that is not supposed to consume by human consumption, we get the restrictions not to allow the food to enter or even the sell in the market. And particularly last session, what we see are different techniques, different methods, and getting the popularity, because every methods have their own advantages, disadvantages. Sometimes some techniques are more suitable for particular category of product. So based on that one, we are going ahead with the safety and preservation side. And now I believe now you have that impression now. We like to preserve the product. Preserve the product means we are maintaining the quality, but at the same time, extending shelf life is a purpose, but we do not compromise with its safety. That is also the concern is there whenever we like to use any technology. And there are a number of benefits what we discuss even about the non-thermal one, because whatever undesirable changes what we found the maximum size happening, that is with the thermal processing, because non-thermal means we're not using the directly heat treatment. And that's why the nowadays if you see in the recent trend in the last 10 to 15 years, there is a quite popularity going among the non-thermal processes for the food processing, food safety and quality side. So yes, the consumer what will depend, they want the product like a fresh like product, so it's supposed to be natural, so they believe it's a product though it's a processing, but it's supposed to have fresh like characteristics, healthier, whatever the for what purpose we are eating that food, it's supposed to be there, safe to eat. And that's why the reason whenever we talk about a non-thermal getting the popularity here. So in this one technology what we are discussing more about, that's a radiation treatment. Okay, so in radiation what we even in the briefly what we say, we have gamma rays, X-rays, that what we are using, that's one of the popular irradiation techniques in terms of product safety and maintaining product safety and product quality, because it is effectively preventing microbial growth. Okay, that process. Even of course that microbial growth, that maybe also we can change here what doses we are applying, and then we need to link that doses. Is it permissible for the human consumption or not? They maintaining the quality. And other thing what we are looking always, there's supposed to be minimal impact, because what I am talking here, fresh produce. Okay, so fresh produce means we expect for the product when we're buying that one, it should be alter or changes with their composition or any biochemical changes with the product. So now the irradiation techniques particularly, they commonly used for harvested fruits and vegetables, even they are gaining popularity in grains, okay, as well as spices. These techniques are quite popular now, the spices and grains category as well. And always one thing whenever irradiation we are talking, they concern about the doses. Okay, what type of doses and what may be the doses range we can see. When we look for the history of the ozone, we can coming on that one, how the changes happening in worldwide scenario to application of that practices. So when the government organization or like FDA from the US, when they're looking for that one, they look at factors when we're using that particular doses. Okay, it is up to a certain level, it's okay, we are extend the shelf life, but after consuming the product, is that some defect on human health or human body actually? So that also looking for, and based on that one they permissible, okay, we allow up to this one, this range of doses, and country-wise it's change also. So now lot of countries, they are allowing the practices to use that food irradiated product. So but make sure actually whatever permissible in India, it's not essential, it is permissible for another country. Okay, that's one clear thing here. And mostly types of fresh fruits, vegetables, spices, on even meat product, poultry product, seafood, everywhere they have the application. Because now if you remember, we have the categories low dose, high dose and medium dose, and like when we talk for the high dose, it's like sterilizing the product, okay, inactivating or killing the microbes which are responsible for spoilage. So each category now, from the fresh fruits, vegetable, meat product, poultry product, or even the grains, they get in the popularity one. And so when we talk about the food irradiation, that's we're targeting the food, exposing food at specific level of energy, and to giving with the doses for a specific period even. So what exactly that one, the food irradiation techniques here prevent spoilage to stop your growth of microorganisms, okay. And now what we consider, they initially come about 60 different types of food, okay. And now you should be aware about world, there may be more than 200 countries, and still we can say some countries still have the reservation about the product, okay, irradiation product. So some countries, so more than 40 countries, they are allowing the product, irradiated product, to come in the market and sell in the market. So there are three definitions coming in that one. First one, radiation, that's the radiation, we can say the emitting the radiation waves, that's energy for the electromagnetic distribution. Irradiation, the process applying radiation to the matter, in our case we say the product, our product, and that's the food radiation because we are applying the radiation on our food one. So ionizing energy into the food product. So coming directly on the product, we may look towards the how the food radiation is applicable to the food. So little bit history side. So in radiation, what we say, we are employing ionizing radiation or electron beams. So when we talk about X-ray or gamma rays, actually, to enhance the safety of the product and extend shelf life by reducing or killing the bacteria or the microbes responsible for the spoilage. Okay, so what we say, up to the certain doses of the irradiation, we not consider, okay, it will changes the product quality in terms of their texture, flavor, or nutritional one, but it is completely linked with our doses. We may see in some examples whenever we go for the higher doses in the composition of the product, it completely changes here. So initially 1950, particularly initially when the irradiation they tried to use in the food product, that's European side, they start to use the application or started the trials how when we use the irradiation product and how it is response from the human consumption. Then after that continued this one, because still I telling this one because now we are in 2025 and still there was quite reservation, and every time we read, every year we get information where we are going for this one. Then to enhance that one, when they're looking for the application, whenever there is something we're looking, okay, we need to preserve the product. The technology is supposed to be cheaper and it should not alter the properties of the product. So then after that there was a joint committee between World Health Organization and FAO, which started to work on that one actually to see the effect on irradiation the product. And then the committee actually what they concluded initially, that's up to the doses up to 10 kilogram, okay, does not have any toxicological or risk for the product. So initially the recommendation was the low doses up to 10 kilogram. So startingly up to they were permissible, not to beyond that one. And now if you see some country guidelines, that one they are also playing that one. Okay, we do not want to use the product beyond that one. Then continue the study was going on that one, so because it was initially early 20th century one. And then based on that one, FAO and WHO had when they come here with the atomic energy one, because India also they are responsible body who is using that irradiation technology, who are licensing that one, that is a BARC. So they come here that they come in the idea here that this technology is a safe for the product, and it's not any harmful effect when consumed by the human and even by the animals. Some products maybe they are looking for the animals. And more than 40 countries or more than about 50 countries, they are accepting or they are using now the technology. Or sometimes some countries may not use because it links with the atomic and with the radioactive materials one, but they allow the product to import in their country and sell in their country. So mostly what we see here, we use the gamma radiation or X-ray radiation. The idea with this one, they have low mass and they have high penetration power. So they can penetrate little deep. Okay. So now you can come here. We have the huge production of the fruits and vegetables worldwide, but the irradiation product is still in the thousands tons. So that is the quite old one, but you can see here the number what we process the product with the irradiation technology is not high enough, still in the very limited number. Like a recent one, initially, because there is some reservation, some concerns with the technique still now. Like in 20th century, initially when the technology peak, so in the whole European Union, if you consider your processing is less than 10,000 tons, it's not a big number for the processed product. So even now it's like countries who has huge production like fruits and vegetables like Brazil, China, they are leading for this one now because we have the huge production and we need to protect the product by using the technology. So you can see here the Brazils or even the Mexico, and particularly now the new application actually what we see in the tropical, particularly in the mango even in the India, in Brazil or Mexico, the application alongside with other foods is more popular nowadays. So in Asia Pacific, when I see here still in the irradiated product, who is the leading this one, this is China. Okay, they have the maximum irradiated product for the consumption or for market availability. Rather than for India, up to now we have the capacity here about 10,000 ton for the process. It's mostly spices, dried vegetable and the onion particularly and potato, because the idea here to stop the sprouting. And mangoes nowadays quite popular because even in India near the Washi they have the center where they are treating the mango, irradiation of the mango. Then we can come here some countries, but one thing you may notice here, now the production of the fruits and vegetables go with the million tons, okay, but still the values what I'm showing here is in the thousands. It may be countries like Vietnam, South Korea, Indonesia, Thailand. The number is not that big for the irradiated product. So concerns are there. So sometimes the agency also looking for this one, so make the awareness for the people that making sure, okay, when you're licking the product, it's not harmful, because whenever they come, it's a radiated one, they get the idea, okay. But now there are also one protocol from the agency they like to make here, whatever irradiated product, they are supposed to have one logo on this one. That product is irradiated product. So application side, if you see the some country like India, we have spices, mango. Some country even go for the meat, poultry. Like Indonesia, we may see here frozen fish or shrimp. And like a Thailand, aware about that one, they are more towards on the food side. Because food side here, the idea is to increase shelf life and delaying the ripening, okay? For example, mostly studies and mostly research, even the mango, strawberry, you can find this one. And for our irradiation one, even the frequency side, what we say, gamma and X-rays, what actually we mostly coming in that category here, gamma rays and X-rays. The idea here for why we selected this one, it has the properties of deep penetration inside the product. So we have E-beam, gamma rays and X-ray. So of course the resource from where we are getting for the gamma rays is mostly from the cobalt 60, from where we are emitting the gamma rays. So for a gamma rays, that's from the cobalt 60, that is where we are getting radiated. For X-ray, we have the energy level like about 7.5 million electron voltage for some countries, and for some countries up to 5 million electron voltage actually. And electron beam with for higher intensity, it's up to 10. Now it because when we're deciding the doses, they can use that one actually with the calculation part. So the high energy electrons, gamma rays or X-rays, have the property to inactivate bacteria, spores, fungi, okay, and indirectly breaking their molecular bond and destroy it and make the product safe. And particularly whenever we look for the the radiation, what we see here, they are the sometimes powerful source what we require the radiation to inactivate the activity of the bacteria, spores or fungi. Then importantly, the most guideline, the country wise or when the food one FDA or FPO, whatever we say here, there is always recommendation what doses, and of course up to low doses there are not much concern. So in low doses, what we say here, we can control insect with maturation stages, means delaying ripening in some cases, and even the stop the sprouting for the product. The medium doses like a pasteurization, what we say 1 to 10, of course extending shelf life, reduce microorganism level, and the doses, high doses is like a sterilization, okay. So it's like if you consider that we are canning the product, so mostly for the spices they are using. Now whatever the study now you look in this one, they are more concerned. In scientific study you may find you are the medium and higher doses, but whenever policy making come, you can find that they are very strict with the low doses for this one. So there are some typically information or recommendation by FDA, like some products like maintaining freshness or fruits, that studies coming on this one for insect, and they come for some fruits and vegetable should not exceed than 1 kilogram. That's our lower dose. Even some poultry cases, that is recommended to control the microorganism. So you can see here, from one thing is very clear, like a 3 kilogram. So you want the low to medium dose only we are targeting here. So frozen meat and chilled meat is also the less in the medium range, 4.5 to 7.5. So mostly cases their recommendation going for a higher one, because there are the chances sometimes the country wise they where you want to send a product, they not have ready to accept this one. Still there is a chances, because what we consider here, whenever they go for the higher doses, maybe the process may be faster, at the same time elimination may be faster, but there may be altering effect, and still there is a concern, because for irradiation they are linked with the even the human, when they consume by human is still safe or not. In the even the gamma radiation, when we say about the cobalt 60, that's a sprouting, eliminate, and that is a quite popular, still popular one. So particularly if you consider this label here, okay, if your product is irradiated 1, even the FDA have the clear guideline. If your product is treated with radiation, consumer must know that one. It's not something the product you are selling and without their awareness you say the safe product something. They must know before making their decision or opinion to buy it not. So they call it a radula symbol, where radiations particularly. So, and like to keep the word treated with radiation or treated by radiation. So people aware. So they're not still now making the doses, okay, it's a higher or lower, but at least a consumer know that one. Okay, I am buying this one, so it is I am aware the product is safe and using for this one. Oh, and particularly in the bulk, sometimes it's individual products come in like a meat one single packaging or something, or sometimes it's like a bulk one. So your cartons comes and you are making the labeling, okay, this is the radiated product. And most of the times such regulations, because those working in the food industry, sometimes FDA regulations that may be mostly followed by the worldwide, because whenever some countries just consider, okay, that is one of the guidelines, though we are not following, and whenever we look for the product make for the export, some countries they don't have the protocol, they follow, okay, what FDA is saying without testing or something. But mostly products they coming with the labeling nowadays actually, because mostly times the product what we're using in India, because we have the facility and they have the near Mumbai they have some facilities where there are onions, potato, even for the mango going for irradiation, but you did not find a product available in the local market. Okay, mostly times we not found the onions, they don't have the sprouting coming, you have the storage one. So they are targeting still for the product, because the purpose here they extending the shelf life of the product and targeting the consumer market. When the cost was, when we discuss actually, that's my personal experience with the people from the bark. So what they considered per kg, the cost of this one is not that expensive, even less than 50 paisa. So because it's like a bulk treated product actually, even if you consider the whole storage of the onions, if you aware this one, it's like a chal and you can treat it in the same chal with the irradiation one. So cost wise is not just about the awareness and acceptability. So when we see here, there are two ways actually. One we say the direct and indirect, okay? Direct and indirect, that's the irradiation now effect on the microorganism. Initially what we consider here in a direct side, that the ionized radiation kills the microbe directly, okay, damaging their cell. It's a directly one, what we say, okay, it's hitting on the direct, okay. So incoming photons, when I saw the X-rays actually hit the atoms of the microbes or the food molecules, and it's most towards the, in real case maybe we always consider the indirect one, but that is one way to consider here if it's a direct one. And because the electron collide with the product and with the neighboring, and it will going to here change their or break their bonds, bond breakage, and it may interrupt their cell metabolism, disturbs and killing the microbes. So that's what we assuming here, direct. But in the reality, every product have the water, not only the direct cell attacking. So that's why the terms coming here, the radiology, radiolysis, okay? Radiolysis is like where the water treated with the irradiation. So mostly food product, we have water molecules. water molecules. The during the process, what we consider here, there was pre-radicals during the radiolysis process. That's the water treated with the radiation happening actually, and we consider here that the pre-radicals, whatever processing during the process of irradiation, they are quietly reactive and try to form the stable product, and then they will combine with another oxygen molecules working as an oxidation agent, and then that process here helping here to damage the bacterial cell component and deactivate or killing the microbes here. So that unstable free radicals react with the bacterial cell membrane and to damage the structural bacteria. So it may helping here to killing the microbes and extend the shelf life of the product. So mostly, though we say here direct and indirect, direct is a more theoretical way we are consider, okay, directly attacking on the target, but is in reality is not. Reality we can consider that is the correct one, actually indirect way. And like most of the times actually in the food one we consider, okay, food is any fresh produce, is the main one is the water, sometimes 80%, 90%, but with water there are another lipids, protein, carbohydrates, vitamins, that are all ingredients also there actually. And when the radiation energy, actually the degradation will come with the water, that's aqueous water in the product, with the food one they call it radiolysis. And particularly product with the water, okay, with the water one we even call it the radiolysis product. So when we come here, particularly the properties of the food, whenever the dosage is higher, up to when we go for the permissible limit, whenever you found the different studies, okay, up to certain level what changes, up to certain low level we are inhibited the growth of microbes or stopping the growth of, even controlling the microbes. But up to certain level, when we go for higher doses, there are some changes happening with, and the mostly studied nowadays, even in India, they're looking the effect of higher doses, how it's affecting the quality of the product, safety, and the challenges here up to certain lower doses, we not found a lot of alternation, but when we going for a higher, the alternation may be desirable or sometimes undesirable with the product one. And even that's why when we say sterilization level, even it may go with the nutritional loss. Sterilization level, you may consider here, we are talking about the high dose, up to more than 30 kilogram one. So there may be killing, process may be faster, but at the same time, if you consider our treatments, actually whenever for higher process become faster killing this one, but undesirable effect, the products which is sensitive for this one, that also happening with the irradiation process. So just to get idea here, when we say here some components from the food, like how it affected by the carbohydrates, lipids, proteins, or water. So most of the times what we say, when we have the radiation, actually the carbohydrates are broken down, easily broken down, and even depolymerization reduce the gelling, and it changes the functional properties from the starch and gums. But during the irradiation, one factor they consider here, effect on as a sugar is not considered here, mostly studies actually. For the lipid one, they call it, because absence of oxygen here leads to cleavage of interatomic bonds, and the challenge again when with the lipids, if you use for any fatty product, it gives smells, okay? It's odor. So if there is some studies actually when they use the fatty fish, fatty meat actually, the rancidity, okay, sir, of flavor that is coming with this one. For proteins, we consider if it's a low dose, it's not anything effect on the protein. Okay, they're looking for the if changes in the protein or things. The dose is supposed to be high. For low or medium, is not have any significant one. And even for some enzymes, they are surviving the high doses even. So now, if you check here up to now, there was a study in the researchers side. Some countries they allow up to 50, but some studies is still going on above that one. If we go more than 50, is that something happening that we can inactivate all the enzymes? Yes or no? If that's the case, what about the effect of other properties? So mostly studies in research lab side, they may coming in this one. Okay, even for the water, they may produce here hydroxyl radicals during the irradiation side. And even for the vitamins, that is the main concern about the food, and mostly times they are quite sensitive, okay, doses. So for if you like to preserve the vitamins, it may be recommending for the lower doses. But now challenge with this one, you like to preserve the product, extend the shelf life, then as a researcher the idea here to optimize the condition for changing to product. But for irradiation, another story is that one. It's not about the product consumption, it's directly linked with the human health as well, because it's consumed by the human. So that's why you found here the research is going on, but not up to that much actually, because as a human health directly linked with this one, irradiation studies. But mostly times the doses up to low or medium level, still some countries open up that one. But going beyond that one, still some countries, okay, they are coming, okay, we are allowed up to 40, 30, but not beyond that one. Okay, so that one, whenever irradiation we say they have the effect, but one thing else consider when I say the effect is more linked with the doses. So when I say the loss of micronutrients, something, you try to get idea here. So the safest level, what we consider, they always come here the low, but we have the limitations. Some properties we cannot alter or not effect on this one. Even for the protein, lipid, and some carbohydrates things, some even they go up to that more than 10, more than medium also, there are slight changes. But there are some sensory alteration, and sometimes the smell or of flavor, that also coming that one. Some studies even they come here for the bread that is made by the flour, because what they coming here the flour using for the bread, they coming with the normally and use treated with irradiation before making the bread, and they found here niacin concentration is higher for the bread that is used by the irradiation one. But even in the irradiation product, some sensory qualities, because at the end people looking to purchasing the product, one thing is may be a very strong statement, that is what we say, it's not something where we say that irradiation we can use for each and every product. It's not practically feasible one. Like when we talk about high fat content like fish, fatty fish or fatty meat here, develop undesirable odor or flavor, because it will accelerate the rancidity during the process. Even at a low dose, particularly for the fatty product, and some fruits and vegetable with the doses, they need to link here how much loss of nutrition, if the sensory one like a firmness is how they affecting on the texture, and they found some fruits and vegetable with the doses quite drastic changes happening with their surface firmness. Even the high protein product, meat or poultry, they found if they do at the direction at room temperature, they getting the off flavor or odor change. So there are sometimes they have the another studies, even they may be playing with the doses actually. So there was something when we see the off flavor and rancidity, there are something high fat beef here. They come here not to go more than 2.5 to extend the shelf life rather than high dose, because you want when to go for high dosing, there is chances of the rancidity for the product, for fatty product or egg or dry egg. So the range around less than 3 kilogram. That may be for the fatty products to avoid the rancidity. Even for the cheese product, up to 3 kilogram, because when we going for a higher one, the challenge with the rancidity, the smell, okay, the smell for the consumers, they not accepting that one. So these changes, particularly whenever they look for the rather than doing at the room temperature, even they can do that process. That may be some alternative. Some studies still going on, rather than room temperature doing the radiation process, why not go at the refrigerated or chilling temperature or freezing temperature to check then, or at the same time what type of packaging they are packaging methods they are using, or even the irradiated product, but rather than store at a normal condition, go with the control condition to control the rancidity. Okay. So now for this particular technology, what we consider here, they have the both way. It may be positive or negative one. Mostly times, so playing with the doses is the very important here. Mostly the sprouting doses, they are with the low doses particularly, they are useful for the sprouting. That is the more concern. Mostly products what they are selling in irradiated one or commercial side. I'm not talking here the research side. Research side we can found the products from the mostly fruit table they are targeting for the research side. But the commercial side, what the product they are looking here, those who are changes to sprouting very faster once they get the favorable condition, and at the same time deactivate the microorganisms. And mostly we can say, okay, how we are doing the process rather than direct, because maybe indirect way to using the irradiation processes. And whenever the doses go more than 10 kilogram, they need to, rather than the quality, but the sensory property is quite important here, because we expect there's some unexpected changes, sometimes some physiochemical changes, and even your sensory properties maybe changes from color to you have the firmness and that type of properties. And even this one more than 10 gray, particularly high dose, you can we can consider it high dose is like our sterilization process, even the structural changes with the product. Even particularly in the radiation side, this also link here to reduce the polymerization and increase the viscosity for the solutions. Even some morphogenetic changes, that is what we are targeting, inactivate or killing that one, that is happening here. And somewhere there they found here that there was higher changes, particularly thiamine, vitamin C. This is quite sensitive with the doses for the product, for irradiation product. Okay. Now when we look here, some studies what they do for the irradiation, particularly this mango here. Here they come with a low dose, actually mango treated with a low dose, just like 1 kilogram. Idea here to extend the shelf life means delay ripening for the product, and with the appearance and things. And then another one, they go here 1 gram, 1.5 gram and 3.5 gram. With appearance side, getting the optimized one, even they go for the higher doses. The quality of the product is not up to that much. Okay. Even if you consider here 1 or 1.5, okay, even if you go for 3.5, then it's not giving you the proper quality of the product. So the mostly cases they optimize, getting correctly optimized one. Then here, when studies on the strawberry, mostly found I not come across up to now the product in commercially in this one, okay, strawberry one. But in the research side, they are looking the effect on the strawberry even. So they get the radiation up to 0.5 and 1 grade. That's a lower level. And where they what they found here, when even go for the 0.5, they able to extend shelf life, whatever the shelf life for the strawberry at conditions, extend by the 3 days more. And even the rancidity flavor, that off flavor, is not happening during the strawberry. So even another one, like you can consider here again the strawberry storage, but here the using the doses 1, 0, 1, 2 and 3, and coming with the appearance, because there in the packaging side, when it's a controlled one without treatment, it's like completely mess up the leaking the water from the leakage one. Even one is not show the quite better result here, that lower dose. So mostly even in the 3 also not, but in the study what we found in the reporting side, that's a 2 kilogram that is able to extend the life of the product up to 2 weeks. But with the whenever strawberry, we consider here the temperature management also the important here, because we cannot tell when we are using the strawberry and you can store at atmospheric condition. Okay. Then there are mandarin even for the less than 1 kilogram, we have the product this way. So even somewhere here, some characteristics of the weight loss or decay with the product, they also we have the studies, and with this one they try to link with the appearance, texture, the decay or weight loss, okay, to link with the different combination of doses. And they targeted here, you can, one thing you can find here, that all look to see here for the low one, because it's mostly country they are permissible for the low doses, less than 1 kilo gray. If it is successful with this one, we get optimum condition for the storage one. So without getting much permissions or much information, it's easy to apply in the market directly. Even for the GAWA one, they have this one, and just to get here, the irradiated one, the GAWA, after the 9 days of storage. GAWA also the quite sensitive fruits, and this shelf life is quite low one. Even after 6 days, is showing the symptoms of the damaging the product. And after 9 days, okay, it's like you are completely loss of the product, but with the like a 0.2, even 200 gray, just like a 0.2, less than 1 actually. That's effective for this one. So sometimes some fruits and vegetable, particularly fresh fruits and vegetable, is sometimes go less than 1. But like a product like poultry, meat, or even the processed food, they may go for the higher doses one. Now for the bamboo shoot, even they look here the products with the irradiated one, just to check with the all physiochemical changes, including decay, firmness, phenol content, respiration like CO2 release, and even the sugar content from this one. And what is the satisfaction? They are able to reduce the level from the weight loss, even the decay rate up to certain level, like even from the decay. And for this one, they are restored up to, the study was they did for the 20 days, means up to 1 month, and still they are in the acceptable condition. So particularly whenever they looking for the factors, irradiation process, so importantly what they look here at what is the surrounding condition of the product. Okay, when we have the irradiation process, much water, because water will tell us the water activity. So what is the dominant process here, even the temperature condition, what process we are doing this one. So these factors actually they look here whenever they looking for the process for the irradiation process, and continue this one if that after processing, if we are looking for freezing temperature, chilling temperature, or ambient conditions. Particularly when we see about the potato and onions, because they both are treated in the ambient condition in our case also here. But some products like a meat, poultry, surely it is recommended that they go with the freezing or chilling temperature. Okay. So when about the irradiation, what the food industry suppose still is a challenging one. You can hear or whenever you read this one, still is not accepted easily worldwide. Okay, so that is the one consideration people supposed to get here, that aware this one, that all radiolytic or irradiated product are not risk for the health one. Okay, when we are using concentration to low, which not harmful for the human health. Okay, and in the radiation actually, particularly when the dose, the speed, the timing, that is also important one, up to what level we are keeping the product, what may be the speed for this one. So even initially, if you see the history from that one, 1950 started to use of the irradiation, and still up to 70 to 80 years, the progress is slowly actually. Whenever FDA coming with some recommendation, and they come here, some processes, some products, they coming stepwise. Okay, now this category of product, if we go up to certain level of doses, are safe, free from pest, parasite, or disease making one, and they can go with that one for the product quality and consumption actually. So, and particularly is still from the researcher side, because when we're listening the expert particularly from this area, the one challenge still about the awareness. Is consumer ready to accept this one? And if they're making the awareness that one, okay, up to low level of doses still is a safe to eat. Of course, worldwide they are doing this one. And then some trials still going on up to higher doses when we go up the sterilized and even beyond that one. And every time we see the regulations, what we have this year, maybe after 2 years they come with some recommendation, okay, the particular product, even you go for the more than this one, and that is safe for the human consumption, or no health risk beyond for this one. So that's why you say here, some product previously restricted in US, because of that one, now they are allowing that one. Okay, now the product, but when it's coming with the human health, the trials and things, it may take the years to come in this one. So no one want to play with the, at least for our developed world, to see, okay, allowing the product, and they have the risk factors with this one. So nowadays, particularly Asian parts, particularly if you consider from the research from the Thailand, particularly industry from the Thailand, even from the India, rather than potato and onions, now the second important fruits they are targeting, like a mango. Because the demand for the product high, but shelf life, the extent of shelf life always the challenging here. And so always think for that one whenever you read for the education, awareness, sometimes, but what I will consider it, when the body at coming with that, people have the impression that one, when body emit the radiation, the product, radiation will coming from X-ray, gamma rays, and when it's this one, it may directly make our health risk actually. So challenging also that part actually, people ready to accept this one. But there are nowadays the studies actually, one survey they did, and when they're looking for the awareness, when they give the awareness for the people, okay, we eating this one, that may be the study happening, and that may be the output from this one. So mostly consumers ready to and show their positive response, they can purchase, and if the available, it added product in the market. So of course there are a number of applications, so we just are showing some applications how the worldwide scenario change for the accessibility of this product around the world. For example, the low dose up to 2, that is quite acceptable now. So the product which will low dose is worldwide, so even the export industry, they can easily adopt this one. And because it has showing minimal effect on the flavor, aroma, now we see the fatty and other parts, proteins, whenever we go for higher, then only we found alternation or changes happening. Then they come here one idea, why not these techniques rather than going the normal condition, it may be go with the modified package or even the controlled storage practices. So just to extend the shelf life, taking the benefit of 2 processes, you are irradiation at the same time you are the storage practices. Okay, so like onion, garlic, where the sprouting we can consider here, or tamarind, they come here commercially available, and in the product looking for the export side, they commonly use this one product now. Even from the India actually, whenever we saw the onion, mostly for the onion, because we did not start here in the Indian side the garlic, because I not come across from this one. Why not? Because we, as we are aware, there are limited centers still now working in that area. Okay. So even from the leafy vegetables from the US now, they approved actually. So one thing you can see, if you see the world papers and today's paper or today's documentation, you found a lot of changes happening. Maybe in previous studies you found, okay, they restricted its product, but now they're open up with the low doses. Okay, just go with the spinach or leafy, because there are sometimes due to there are some contamination due to E. coli, and to prevent from this one. For some countries like Japan, they give the permission up to less than 1 kilogram for this one. Just idea, because their idea is here to prevent the sprouting from the product. And even for the potato from some countries like just insect disinfection. So now one thing with the clear with the irradiation process, what we come, we cannot say it is very strict recommendation for this one. Some countries make the recommendations more linked with the health concerns. Okay, sometimes they not want to go for higher doses, because still some studies with the human health may be recommended for this one. Once they approve, they may come with it sometimes, but mostly found with the spices, they are still coming with the little higher one, up to 10 kilogram, some recommendation. But when I say the sterilized one, is like a still in the debatable questions, shall they accept or not. But with the coming result, coming solutions, maybe combination of another techniques with this one, and come with the potential result for the people, it may be changed. So particularly for irradiation, you may come with, sometimes you read some recommendation even from the bark, particularly for the food category. What may be the recommendation doses? One thing we clearly get here, higher doses process may be faster, more effective one. But what about alternation, and what about their effect on the human health? So we start with the irradiation process now. Okay. Okay, thank you for this one, and any queries, questions?
Are there any commercially available irradiated products in India?
Frankly, we have the techniques, we have the facility available, okay? But mostly product, what we aware this one is for looking for the export market. So we have the facility, okay? We are doing the irradiation process. So for example, if you aware, because the center who is giving the permission to use this system is the BARC from Mumbai, okay? So if you want to use the irradiation process, irradiation techniques, you need to get the license from them. And they have some vendors, they will set up the system for you for the product with all guidelines. So India mostly, if you know about Nashik, which is the famous for the onions, okay? They have the facility for the onion and mostly targeting with the export. Then they have another in the coconut belt, we have the mango, lot of mangoes, the facility for the mango, but the mostly products for the export market, okay? We have the facility, but not available in the market, local market.
Thank you, sir.
So, sir, I would just like to start with your last statement, which you said like the higher the doses, the higher will be the irradiation,
Yeah.
or higher will be the sterilization effect which will be seen.
Yeah.
So as a regulator, so what should be the consideration that I should take in like into my mind before deciding the upper limit, upper high limit for the commercial level?
Particularly for this one, what to pay, because we like to bring our product as a commercial level, okay? That's one idea with this one. And if we targeting the states, US, and they come here up to 2 kilogram we have no restrictions. If going between 2 to 10, if we have restriction, okay, we need to give your complete study, and they have the reporting, okay, up to 10 kilogram with the product is not have any adverse effect on the human health. So it was really suggesting that one we need to work in that window beyond that one. Now in the researcher side, I come across actually, they work in some studies even go up to 30 to 50 kilogram, and they found some excellent result for the preservation side, okay. But the lacking is they cannot make it technology commercial available, because we like to get also the study related to human health, how it's affecting that one. So I still believe in this one. If you're targeting what particular country or particular product, so that the guideline that up to 2 kilogram is the acceptable, maybe that window may be playing better rather than going higher.
So I have a second doubt which is related to this thing. So we talked about higher safe limit, right?
Yeah.
Let's talk about the lower safe limit also.
Yeah.
So we generally read about one experiment in our bio books and that. So in that experiment, so they take a infectious strain, that Salmonella one, which is very common in meat, and then they heat treat it and make the bacteria die.
Yeah.
And then they take a non-infectious strain, and then they keep in the same you can say the vessel, but that also started behaving like a infectious strain. So when I treat my product with the lower safe limit, like lower level of irradiation and then lower gray, so if the nucleic acids are not damaged properly, then it might convert even the non-infectious strains into an infectious strain. So with that, keeping that thing in mind, so how we can trust irradiation action?
No, my concern is now, it's not, I'm talking about the product safety. Is here the main concern about the irradiation after the Japan event, okay, nuclear one. People are more concerned about the stresses of irradiation in the product. So we not hear about the food safety side, we are fine actually. They are looking here the stresses of the irradiation actually for the product. And that's why the human health, when I'm talking about, it's not I'm talking about if they are microbes or any other factor, they are maybe still affecting the quality on that one. The people more concerned about the, if there is a irradiation and they concern, they may be stay for the years. So that was the mindset particularly for this one, irradiation concept.
Okay, thank you, sir.
Yeah.
Good morning, sir.
Yeah.
Sir, there is some terminology when it comes to irradiation.
Yeah.
When the dosage of radiation is in between 1 to 10,
Yeah.
it is termed as radorization.
Right.
When it is in between 10 to 30, it is termed as radicidation.
Yeah.
And when it is above or when it is in between 30 to 50 or more than 50, it is termed as radiprotization. So when I want to preserve a food product, how come I know which frequency or which dosage suitable for my product of interest?
No, particularly if you consider here the fruits and vegetables, they always go with the lower side actually. Even mostly studies the recommendation even the less than 4 to 5 kilogram. Okay, for meat product is little bit higher side, and the spices particularly if you see the 10 and around the 10 and above 10, but the sterilized one when we say the above 30 or highest dose, still in the research side we can do that one, but still the acceptance from the or approval from the authority still is in the question actually. But the product what we're looking for, if it's a fruits and vegetable, it is always recommended go for the lower side, even some studies even less than 1 kilogram. But processed product may be little higher and spices little higher because it's a dried product.
Okay, sir. Thank you.
Good morning, sir.
Good morning.
My question is, sir, does irradiation technique delay the process of ripening in fruits?
Yes, mostly for the mango what we're using, that's the idea was to delaying the process actually.
Okay, sir.
And that's Mostly because dealing that's Thailand, particularly Thailand and India, we have that facility
Yes,
because
sir.
we are the one of the biggest producer in the mango, and they're trying for the mango. And for mango, they are looking for going for the higher doses, but the challenge the same one actually.
Yes, sir. Yes. Okay,
Is
sir.
it accepted by the outside or not? We get the approval.
Okay, sir. Thank you.
Okay, okay, thank you.
Thank you, sir, for your informative session on irradiation techniques, indicating the effects of irradiation on food quality and keynotes on quality of irradiated foods, sensory properties of the irradiated foods with real-time examples. Sir provided the content on safety aspects of irradiation in the food industry and its application. Now, I request participants to break for the tea and gather here after 10 minutes for the next lecture.
Okay, okay, thank you.
Over to you, sir.
Hi. Welcome again. So we continue with the second technology, that's a non-thermal one, like a ozone technology, which is used for again for the fresh produce quality and safety side. So what we're dealing actually all about non-thermal techniques, okay, which towards the food safety and preservation. So we starting with the ozone, and as we come on now the non-thermal one, whenever we're discussing from the last 3 days, that's what people like, because in whole scenario you realize one thing here at the end, consumer is the king, what he expect, okay. And at the same time, when we see the post-harvest losses magnitude, looking for high losses and increasing the population, the idea here, we have to be some techniques, green technologies, okay, or environmental friendly technologies, which is helping here to reduce the losses, at the same time maintain quality and have the enough product. Or when the population, when we estimated that in 2015 growing by additional 2 billion people from today. So idea here to how much we can preserve the quality product for them. So whatever the human consumption we can see for the products, we have the sources for our energy, including protein, nutrient, it coming from the fresh produce, fruits, vegetable, and even sometimes we can go beyond for the food product, because the ozone, when we're talking about ozone, we have the application, even the grains, cereals, even, okay, even with that fruits and vegetables, we can found nowadays the application in the cereal part actually. So when we took for the magnitude losses, and still the consideration is that one, fresh products have the maximum losses, okay, maximum losses. And the idea here, both when the population is growing and keeping the product for the them, alternatively we need to increase production, but alternately we have the limited land now, because every time we get decreasing. And the another one, it's supposed to be link your production improvement when we look for the basic agriculture side, when the biotic and genetic changes happening, even the modified foods. But link is supposed to link with the ignored things, that's a post-harvest actually, where we able to maintain the product and availability of the product for the people throughout the year, and it may make towards the achieve the food security for this one. So when we look for the preservation side, Preservation, when we talk here, not a new thing. Even our forefathers know that operations, okay? Even if you see our grandfather, if you ask, they have the techniques. Sometimes our drying, even the pickling and other operations, they are doing that one. Preservation, they are doing lowering in the slow temperature, even sometimes some traditional practices just covering the fruits with just avoid oxidation and preserve the food for a longer period. So idea here to challenge here to look for the technique that may be environmental friendly, best for even economic better, and at the same time without compromising the quality of the product. So that's what we always looking for. And the idea here, the spoilage supposed stop means we need to inactivate or kill the bacteria, microbes, which is responsible for the spoiling or damage our product. So it is also linked with the, we need to maintain the product quality as well as not to compromise the safety side. So that all included here. So we advocating from the last time also advocating with the non-thermal one. So now rather than repeating this one, we come here for the thermal and non-thermal one. So for the mostly products, whenever looking for the product with the maintaining the good better quality, mostly technologies they're looking for non-thermal one, and of course there are number of technologies even for non-thermal, and every day we can found here some changes, some ideas will coming on that one. So in the nowadays we discuss about the cold plasma irradiation, other parts, and now today we are looking for the techniques with the ozone. Ozone, how the kind of application even for the food preservation, even if you see here is what like a sanitation for the food plant products. Even for the industry where use of wastewater and treatment, that ozone treatment now they are commonly used here. Now come here for the food decontamination methods for the fresh foods, even the cut foods they are commonly used. Even the, as we mentioned, not on the fruits and vegetable sector, you can go with the grains and cereals for this one. And they have the properties for sanitation even the surface side. Even in the food industry, what we looking for this one purpose like a chlorine and things, and it has a better effect compared to this one. So even in industry side, they looking at commercial application, and particularly they looking to replace for the common sanitizing agent. So mostly in the industrial side, that's a chlorine they are commonly used. So this is quite a environmental friendly application and even maintaining the better quality product. So this one again we come with the ozone, particularly I come with the historical part here. So around 19th century in 1840, so that was the first time they found here, that is the gas actually, that may be ozone, not application side, that may be the O3 we can utilize for this gas for the application side in the food. So for the ozone, now we get it O3 means 2 O2 plus 1 unstable bond, that's O, that's become our O3 here. So for the ozone properties, they have melting point and boiling melting point up to 112 and melting point about minus 193 degrees Celsius, and the properties of compared to O2 is a completely changed. Even is the density of ozone is 2.14 gram per liter at 0 degrees Celsius. So even the gaseous ozone, what we consider is more denser than the air. So we consider is a diatomic oxygen. That's so when we say the O3, that's our diatomic oxygen, and it may create in the atmosphere by lightning in the sun rays, okay? And naturally, even in the sun rays, all ultraviolet rays, what will happen in the sun rays? It will break down the bond between O2, and that we have those two weaker bond, and then another O2 they try to attach one like unstable way. Of course, that's what we're talking here from the natural side. So it has larger oxidation potential. That's why it's used as a sanitization process for the mostly fruits and vegetable, and it has also have the characteristics like a strong and highly reactive oxidant. But for ozone, we can come here one part here. We cannot buy the ozone. Okay, we need to generate the ozone on site. So you cannot see we can buy from market or available in the market. So ozone mostly whenever we like to apply the ozone, it's supposed to be generated on site, and then we can apply the ozone for our application part. So we create the ozone here by two ways: corona discharge or UV rays, and that's commonly used. That's creating the ozone with the ozone generator one. So when we generating the ozone in the process, it's not only the O2, O3 we are getting here. With the O3 we have the another additional substances that may be additionally getting, that's including hydrogen peroxide, nitrogen oxide or nitric acid, with coming with this one. And particularly the O3, when we say here for the ozone formation one, that's we have O2, that's we can diatomic because it's a 2 bond, 2O, and one when we break it due to sun rays or even from the UV rays, and that's what we say the unstable one, and that make us triatomic molecule. And that's what we mentioned here, that is getting from the electric discharge or electrochemical process or our corona effect, actually electrical corona effect, to making that O3 here. And these methods commonly used, particularly mostly what we see in the popular one like a electrical corona effect, actually that where the corona ozone generator, actually they're based on this one. And again, whatever the food quality, again you concern here, because even I are talking here the FDA again here, that's 1997. After ozone we identified 100 years back, that may be the agent that may be used for the food preservation. They recommended now you can use the ozone as an agent for the food preservation. That is a safe according to all guidelines to application from this one. So mostly times we are aligned or food research, food safety research, whatever the recommendation by the FDA. And even this one again after later stage, it's you as even you can use that ozone as like a microbial agent, okay, for the storage processing of the foods. So idea here to eliminate pathogens, sanitize the food, even in the process side, in the plant side, you can use that process. Okay. Now, what we came the ozone here, one wood is which is a highly unstable. So it will rapidly not connected with this one, it will connected directly contacted with molecules from the food materials. Okay. And in ozone side, of course, this also I mentioned one time, that's we need to make it in the places itself. And for the ozone, again the properties, the ozone commonly is a gas, okay, it's a gas, and which is slightly soluble in water. And for because they sometimes the ozone properties when they're using for the food quality and things, they maybe look for this one, as ozone degrades very faster one, but its half-life of its gaseous state, half-life of the ozone in the gaseous state is higher than aqueous state solutions. And particularly the ozone in unstable, and that's the benefit we are taking for the process actually, because it's unstable one, but they are more unstable in the air, stable in air but high in the water actually, high in water. Even in the byproduct, what we get at the end, that atmosphere oxygen and its residues, there are some process at the end. After the process happening, our ozone treatment process, it may return to the air without making harm. So mostly we consider that process is an environmental friendly process as well. Again, one characteristics, this one for the ozone air, ozone we can make with a two with like a air or the pure oxygen. Okay, with the pure oxygen, and mostly in the process, even in the if you the ozone generator, when we use in the air, the idea here to get a dry air actually, and that time the ozone is the blue gas, its color is looking like a blue, and when you have the pure, or when you are making the ozone from the O2 direct, oxygen directly, is a colorless. Okay, so when we consider here ozone is highly reactive, the idea here, because it's unstable, one bond is unstable here, so mostly of course it will getting on site, that's the reason. And mostly studies we can see here, there is a concentration as per our requirement, what much doses we are using for the product and for how much period. So both way we are looking here, depending on the concentration and for what purpose we are using. We are looking for the sanitation or processing, or what for the requirement for the product, for looking for extension of the life. So here again they make here, when we generating the ozone, that UV radiation that have the nanometer length, just to breaking up the O2 to separate O2, and one bond may be attaching with another. So when it passing through that oxygen molecule with the broken up, and then that joining with the another O2 directly, it's like a O3 process we are getting here. And particularly when the factors, when we consider here to generating the ozone, that's what the voltage, the frequency, discharge gap, the thickness, that's particularly what we say when we generating the ozone. So mostly the ozone what we presented two ways, one with the milligram per hour or per ppm, parts per million. That's a commonly representation of ozone concentration. And what I mentioned there, one part here, when we are generating ozone from the air is supposed to be dry up. Okay, if it's, air is not dry, there is a chances of nitric acid formation. To avoid that one, we need to make it dry. And of course, this was in the, when we make it from air, it's like color like a blue. If it's a pure air, completely colorless, ozone is completely colorless. Then what we say here, ozone's because we are dealing with the ozone properties, it has a lower partial pressure, and but it has highly soluble in water compared to the air. And mostly cases when we generating the ozone at low temperature and higher pressure, it may be give you the concentration of ozone is a higher type. So in ozone production, particularly they look at the condition before we are generating ozone, what is the environmental condition, what outside temperature, because we consider here low temperature, that may be a good part there. Then what type of food material we are targeting, okay, is mass, volume, how much concentration we require, if it's a product with a high water means it has a water activity higher or lower, how much microbial load on the product. So all the factor we consider actually how much ozone we can require or what may be our dose for ozone. Then what ozone we are getting, actually we are getting the ozone from where we are getting, then the quality of ozone we are getting from air or getting from the oxygen directly. And then we look here what type of the doses based on our treatment. Actually finally you are going for sanitation or processing side of this one or killing the microbes. So it's just like a simple process. Maybe we have the commercial one who are generating the ozone setting one. Now here from the oxygen tanks or sometimes maybe directly from the air we can have this one. If it's oxygen tanks, maybe you are getting the pure oxygen, so you get the ozone. Otherwise you have the oxygen air where we need to dry it up in the system to pass into the generator. And then we have the treatment chamber, but now here we have the ozone destructor actually lastly, because after processing this one, there may be some component that may be coming with the oxygen that may be destruct here before passing the pure air to the environment. So just to getting here the purpose of that, here full oxygen concentration, like the generator, we have the O2 generator box where we are getting this one. One is we have the cylinder of oxygen from where we are, otherwise the air. Based on the getting this one, if you're taking the ambient air, our first idea is supposed to be clean. So whatever the dust particle is supposed to clean up with the filtering one time, and then we have to remove, means dry up. So it will help here to possibility getting the nitrogen there. So just to idea here, removing the nitrogen, so percentage of oxygen supposed to be increased here. And of course when we are looking for drying, so is dried at desired dew point temperature up below 4 degrees Celsius. So even in the generator there are two processes commonly used. It may be UV generator or coordinate generator. They are the most commonly used for the ozone generator one. There is a flow meter just to get here idea what is the flow of oxygen we are passing and at the end, and what is the concentration we looking for the oxygen we are supplying here. The treatment chamber, where once we get the ozone for the treatment, where we are keeping the fruits, vegetable or any product for the processing one, we are passing the product from the top and getting back from the treatment. Now always the challenging here ozone analyzer actually. The challenging part here because what is the concentration that is absorbed or utilized during the process. So how much that is absorbed and how much leave the treatment chamber, they need to measure this one actually. So that is utilize ozone for this process. So there are some techniques, some methods to measure this one. And last one, when I say the destructor actually, because it's like an outlet. So whatever the excess ozone that is not utilized, that may be destroyed. And the purpose here to clean up the air, because before going to the environment, it's supposed to clean up or decontaminate the air and then pass to the environment. So for the ozone one, the ozone measurement, there are different techniques, different measurement methods where to measure ozone concentration. Ozone concentration. So one is iodometric methods. So with the help of pre-iodine plus ozone plus air, we are looking here to get the concentration that is utilized for the process. Another one like indigo trisulfonate methods, sense methods, and UV absorption method that is nowadays used with the UV. Okay, so they use our Beer-Lambert equation. Those who are working the UV, this is a similar equipment where we can use for this one. Just to look here, for we have the molar absorbability for this process about 2900 per meter, and this is the standard protocols or standard equation just to measure the concentration, which may be little challenging how much ozone is utilized for the processes. Now the interesting part with here how ozone treatment works for this one. Now we get one idea here, even we discuss this one. With corona discharge or UV rays, which is helping here break up O2 to make the new bonding. So that unstable, that's a broken single O, try to connect here with this one, but it's always the weaker. That's why we say here unstable third oxygen atom of ozone, which is the unstable, and that is the helping here to decontaminate or going for the processing side. What it will do here, that unstable bond whenever contact with the material, that's any organic or inorganic molecules from the food product material, with the contact with due to oxidation, they are try to destroy it, and that is process of destroy that one through the oxidation. Another one, particularly if you see in the grains, if they using for the grains for O2 if the insect is there, okay, sometimes the insect we say they have the issues. If the insect inhales that unstable O, it will die actually. So even they are using for the grains. And that big breaking that one and making that big bond always utilized here. So the oxidable substances, maybe they are with the algae, bacteria, fungus, virus, they are contacted with this one. So when we look for the how it affecting on killing the microorganism, just to get here one thing here, because ozone, what we known for this one, it has high oxidation potential. That's one of the characteristics for the ozone here, and that is helping here to lysis the microbial cell. Microbial cell, that's directly target on that one. So directly killing this one. So there are involved two basic mechanisms for ozone destruction here. First one, that ozone oxidize the sulfadiol group and amino acid, first one, and then the ozone oxidize the polyunsaturated fatty acid. Particularly if you consider this way, actually our unstable bond, they may target with the SH group with an amino acid is the first side, and second one like enzyme and protein side. Now when in the process of the oxidation, there is a cell breakdown and leakage of cellular contents and causing the process of oxidation for the unsaturated lipids of the in the cellular membrane. And this may indirectly link here date of cellular date. Even they come here with the ozone sensitivity is quite higher, and there is a chances even changes in the viral protein code even during the processes. So the process what we see here, particularly in the microbes side, we can say the two steps. First is our SH group and amino acid, and secondly with the peptide protease and linking with the cell date. Now in the ozone, because it's like a non-thermal, quite people looking for the environmental friendly technologies. So mostly food application, starting from the spices up to the dairy industry, they are quite popular. Even some applications, because the spices why we using their volatiles is quite important. The volatile components incorporated to this. Dried food, grains, meat, poultry, food, seafood, even the liquid as a dairy. So its application is wide. Nowadays, recent one, rather than fruits and vegetable, we can find quite long studies coming on the cereals and grains actually to apply in the particularly the ozone treatment. And yes, it has the capacity, it has the maybe looking for potential, because now in the industrial side, what the sanitizer we are using, like a chlorine stream of hot water, maybe coming period we may have the potential. Even it has performance wise, when I check, it's more than 1.5 times better compared to chlorine, the performance of the ozone here. And even it is a safe product to use, and even it's a natural, considering here what cost effective, chemical free. So it has, that's why it's maybe getting the attention nowadays actually, ozone treatment for this one. And it shows here when with the unstable atom contacted with the product, it has able to kill or inactivate, including the all the parameter, all the organisms from bacteria, fungi, yeast or parasites. Even in the product, particularly, you have the one thing is it may be working at the surface as well as in the inside the gaseous state or in the dissolved in the water, because we see that there is a properties of the ozone, it may dissolve in the water properly. Now there are some studies, particularly ozone, they come here with the treatment, and they come here some particularly in the research side, mostly they look for the ozonated one. One is the what we more interested about, the what's the concentration we are using, okay? And when they use for the cabbage here, the concentration is 2.3 milligram per liter, and but now challenging, because as a researcher what we always do is to optimize our things. So 6 minutes they found optimized condition where they able to reduce all the bacterial count by 90% with this process. Even for the grapes, now one thing you can check here, every product to product, there are something we may check here, that's a concentration we may utilize as per our requirement actually. And they look for the grapes one, for the bacteria, fungus or yeast one, even increasing up to 8 milligram per liter, but now the timing is reduced up to 20 minutes. So even the ozone, they are used for the treatment, for the surface treatment, it will helping here deterioration of the fungal from the surface from the product as well. Even for the onions, nowadays the ozone is commonly used, particularly because what simply you come here, whenever bacterial counting we are talking about is has a property to make it down and not major change or desired changes happening with his composition as well as the sensory properties. Even for the dates, they have good one, like they show the concentration in the 5 ppm to maintain the quality for the dates. So for the berries and for the apple even, so most times, as we mentioned one again, the units we can represent it for the ppm or milligram per liter or meter cube. And there are two things actually whenever you like to do in the research in this one ozone state, we like to play or understand the concept what is the concentration. Of course it's a link with your purity of the ozone, it is coming from the air or from the oxygen directly. What's the concentration we are using and what's the timing we are using, because we like to see the effect on whenever it like sensory characteristic, physicochemical changes happening with the product or whatever the microbial or bacterial things, how we can control with the help of this one. Then another challenging part with this one, okay, for the fresh produce with the uncut one, this is commonly used, but again the challenges come when we look for the cut one. The process, oxidation process, biochemical changes happening very fast, and controlling with this one also the challenging one. And there was the study particularly when they look for the fresh cut apple and onion slices, even they come with the bacterial as well as the textural properties actually that may be maintained throughout the process due to ozone one. Even for the chopped peppers, and this one for the meat one. But when they do this one, they look for the higher temperature compared to not with the lower storage condition, this one. Even just to looking at application for the wide variety of the food product, even the fish fillets, to controlling the microbial flora. Then for the grains, as mentioned, it's a grains is quite common use, particularly maize, corn. There are, you can find it a number of studies coming on the corn and even our rice actually to maintain the quality, because it's a main concern with sometimes the changes in the biochemical, but even the insect, okay, alpha toxin, that all the things we can control with the ozone treatment. Then for the flours, dry powder, wheat kernels, and even the liquid product for the milk, even they use the ozone for the treating the product. Even the firstly when we see the cabbage one, when they look for the fresh cut cabbage, always the we're dealing with the post-harvest and food side. When the product we deal, if it's a complete cabbage, how we facing the problem for controlling is maintain the quality, and when it's a cut one, it's a completely change the product characteristics, okay? Because what we aware this one, as soon as we cut the product, a lot of biochemical changes happening. The respiration, transpiration, ethylene suddenly extend by many folds actually for the processing product. So when they using the ozone here and looking for the different doses from different timings with the ozone, keeping the similar dose, and looking for the respiration and transpiration and they found it when we treating for the longer period, it giving that the better result in terms of respiration, ethylene production. At the same time, acceptability, but acceptability you can see here little bit contrasts the result. Actually the acceptability they found by the appearance side from the consumer side when we keep it for the 5 minutes. However, in the respiration and ethylene production reduction we get for the higher period. So we need to combine that all the outputs actually when we looking for our next research, particularly that area. And of course the storage goes up to 12 days, and it's a challenging for the those who work in the fresh cut industry. We can understand this is a challenging task to extend the shelf life for fresh cut product compared to complete one fruits. Even for the onions, for the slicing one, they found here with they come with the different treatments, different timings, 1 to 5 minutes, and of course whenever we go for the lower side, means higher side of the period, rather than changing the dose, we can control the chlorophylls, yeast, and even the respiration. But you can found again one thing here, the chloroforms and yeast is not directly linked with the respiratory one. Respiratory one with the timing is also changing, what we are expecting here. Then again for the fresh cut lettuce here, they have looking for the gallic acid, lactic and aqueous doses that's combining with that one, going for the directly ozone or maybe pre-treated product, and how the result will coming out that one, or weight loss or electrolyte leakage for that all combinations, if it's working or not, that because it's just like ozone plus we are another treatment we are doing here. Even it's for the leafy vegetable like a spinach, and looking for the characteristics, particularly chlorophylls, flavonoids, and how it changes with the ozone one, and with the storage period up to 12 days with the spinach, they are looking for this one. And sometimes we come here with this one with the when we see the chlorophyll one, that is a high maintained with the ozone treatment. Similar for the apple slices, for ethylene or PPO activity for this one. But for this one, when we are looking for the product one, what is important here, it's supposed to link with the overall quality. Overall quality, they come here sometimes with the sensory one actually. Is the technically we see the product is safe or something, but what about the physiochemical properties that's accepted by the consumer at the end? Even for the bell paper, now is this one, they try to link again with this one. Sometimes rather than going for the ozone, we treated the ozone, and why not keeping it the regular storage condition, then it may be linked with a MAP or CAP or any cold storage condition with the temperature management things and how the effect is changing. So even it is like a hybrid system they can make here for that process. Even for the kiwi fruits, we're looking for this, and the mango. For mango, the storage period what we have in the ripe mango is about 1 week to 10 days. Okay, we can store it. Now the studies they able to extend up to 4 weeks, but the treatment what we see here, the quite longer period actually, quite longer period for the ozone one. here just to check here there was the same timing, but they try to change the doses. They try to change, rather than changing a timing, now change the doses of the concentration of this one, ozone one, and here little bit contrast result. Sometimes we found that treated with higher doses and with the lower doses, not directly significant way coming the result one. Like if you see when I say this one, particularly this one, when we have the lower dose, but when it coming for the last days, it is little changing with the weight loss. It is accelerating on latter stages. So when we come with the process of when we using for fruits and vegetable for ozonization, there are, of course, there are pros and causes for every processing system when we selecting for the product, and mostly for the it has a capability, particularly when we looking for the positive side, it has a capability of highly oxidation, and that's why in coming period when we say the industry is looking for something replacing maybe some times of chlorine or another methods to the ozonization, and even it is helping here the product to stress abiotic stress part easily control cell wall activities resistance for the one target here mechanical damage actually whenever handling that one. So just considering that they up to certain level, because what we're talking about initially mechanical damage at higher level is difficult, but the cell wall become little stronger or enhance the resistance actually, the preservation of vitamins, and at the end it will not keep any residues, so the air can be reutilized in the environment. So and processing time also not faster, processing time faster, so you can do the process very faster when, and what it's doing here is a control or stop the growth of microbial, enhance the some antioxidant defense metabolisms to prevent the product here. Particularly when supposed to technical side, when we say there is some negative points as well, we not say it's as the agent or that's unstable one is a quite active one. Okay, so there is chances to processing very faster when sometimes desirable or undesirable, then sometimes mitochondrial oxidative stress happening with the product, and when it's looking for sanitization of surface one, so most of the times they recommended not for this one, so they consider it may be damage internal cellular integrity. Sometimes some studies actually they come with some sensory, because we found some studies actually in our cases the characteristics of respiration, ethylene and others are for some condition higher, but accessibility score by the sensory it was different, because sometimes the physical appearance from the product is not up to that mark, sometimes changes in the color with the when we go for the higher doses one. And so the again what we say the aqueous form of ozone is less soluble in water, so it has a quite shorter half-life of the product, and it may come with when we use the not good quality water. But particularly in the processing side, when we see here they're taking that one when it's like used for the water treatment. Okay, water treatment. But in the food and vegetable industry, when we're looking for what, this may be overcome easily. So, in when we're looking for that ozone side, actually, now the industry what they're looking at, as a consumers, they come with the environmental friendly, not treated with any chemicals, not treated with the chemical. That's what we're looking for, the good quality product, and they may be getting the popularity coming days actually. Even last decade, not a decade, 10 to 15 years, the research side wasn't getting the whole popularity. At the same time, industry, we found lot of industry involving in that one, the processing unit, applying the in the sanitizing side or processing side for the product. Even for the range from the all type of food material, from the grains to the meat to the fresh produce and even fresh and cut product, even the flours. So we stop here with this one, with the application side of the ozone. Okay, and thank for your time again.
Good afternoon, sir. My question is, how ozone affects the polyphenols in fruits and vegetables?
Particularly, you are talking about the polyphenols things actually. So, when we say here, mostly is, the ozone is we are using for the surface treatment, okay? Surface treatment. And with the surface treatment, we're not directly coming in the polyphenol and this one, not direct studies with this one, what we show here. But the processing, how is happening with the product, with the molecules which is responsible for PPO. Okay, this reaction with our unstable oxygen, because if you consider the reactions, what will happening with the all molecules which is responsible for the changes.
Okay. Sir, one more question. Oxidation of polyphenols are not favorable to the vegetables and fruits. So how could ozone be advantageous?
I'm not.
You are not audible, sir.
Repeat one time.
Sir, oxidation of polyphenols are not favorable for fruits and vegetables.
Yes.
So how could ozone be advantage for the use?
No, but the purpose actually, for we are using the treatment for with have the different target actually.
Okay.
Sometimes your target is like looking for the microbial. If your target is PPO, maybe not this one, but if your target with the microbial load to stop, and it is in that link with your PPO activation. So the particular the technology what we are looking here, what we are targeting actually.
Okay.
Yeah.
Thank you, sir, for such an insightful session. My question is related to, as we know, ozone is naturally available in gaseous form.
Yeah.
And here we are using ozone-treated water. So basically I want to ask, can we, like for chips and all, we are using nitrogen flushing. So can we directly use ozone for those kind of products?
Particularly dried product is maybe possible, because now when we're looking for some dried grains, dried spices, rather than directly flushing this one, but I maybe it's a very strong statement to tell you that some studies are basic studies for this one, but it may be possible because the moisture content for your dried one is also low, and your target is for the keeping the product whatever the nitrogen flush. But it's a possibility to use this one actually with that product. You can use this one.
Thank you, sir. I have another doubt. Sir, we are using this for sanitation and decontamination also.
Yeah.
So basically it is affecting the microbes.
Yes.
So what are the chances of it affecting other biomolecules, desirable biomolecules of our food product like proteins and carbohydrates?
Because mostly the studies what we see in the ozone, you not documented that part that intensively. It's like a surface decontamination, that is the one surface actually what we're looking for that one. So if you see the deep this way, there are not much documentation, particularly this one. So
For some products we have used slices also. So
yeah, this may be for the fresh product, that's this one, but in the processes where you are the fresh cut product, there is a chances to affect this one.
thank you, sir.
So it was an insightful session, no doubt. So whenever we talk about ozonization, right, so we try to replace the chlorination, right?
Yeah.
So both beings the radical,
Yeah.
like we are using chlorine radical in chlorination
Yeah.
and oxygen radical in ozone,
Yeah.
right? So my doubt, it's not a doubt, I want to actually know your view. So which you have well covered in the pros and cons slide.
Yeah.
So one of the cons that we, which like you have mentioned is discoloration, right? So when I actually treat my or wash my vegetable samples or cabbage or something with ozonated water, so I am actually letting the oxygen radical come in contact with that particular vegetable, which activates lot of enzymes like polyphenol oxidase and peroxidase. Degradation due to in the color and quality with that enzymes is much more than the effect of ozone we see in the sterilization or maybe decontamination. So how far you think, like when I go to some industry and tell them to replace the chlorination method which is not activating these enzymes, how far like we can do it, or if at all we have to suggest them, so what additional technique you suggest to do in parallel with it?
Because when we look for the when we compare with the chlorine, actually you are correct in that way, because some enzymes and the colors that maybe we are getting better with the chlorination actually compared to when we take the ozone one. But when we're looking for what's the targeting product in that, if you are maintain or you are looking for desirable changes with the enzymatic activity for this one, that's also one thing. And another one, like we try to come with the chemical pre-process, so that way it will go actually. Not directly in that way we can maintaining the chlorophyll or color with what enzymes we are activating, deactivating with the processes. But another advantage, if the product rather than chlorine, and we would like to away from any chemical one. But it may be how some industrial doubt, particularly because they want to sell the product in how they want, look like more changes or desirable changes with this one.
So do you have any experience with some similar for the industry, like which they have asked to use the ozone, and then they have maybe to resolve the problem of discoloration?
Particularly only what we have some experimental side one, not with the industrial side. That's why I concern with your point. That is something valid point even.
My next question was with respect to slide number 25. So in which you have taken, this is a research study.
Yeah.
So in this you have taken overall quality score.
Yeah.
And as we can see from the control samples, it is actually linearly getting decreased, right? So which is a bit of, how like whether they have used the the samples with some kind of packaging or something, or because it is very much linear. And with respect to same results in slide number 29, this was not linear in control samples. That was with respect to apples. So how, like both of them is a bit
Actually, the things here with the storage conditions, okay, for both cases, it may be different actually for both cases. Not about the treatment, okay, treatment time, storage condition. It's like a cabbage, even in the, what we say, the particularly apple, there is a chance of getting oxidation very fast. And this may one reason here, the control samples overall quality loss is complete decline. Okay, of course they also decline, but it's a very steadily decline, this one. And in this case, actually, the expertise score, when we see here, is decline with the time, with the after 8 days. And again, one thing you can see here, with this storage study just for 12 days, okay? And however, the Apple study is a double, I believe. No, it's also 12 days actually. But reading times, okay, just come in this point, because they check with the similar way ethylene and that part, and ethylene reduction is fine, but your expertise score with this may be linked with your physiochemical changes, and oxidation may be quite higher with your product with the control situation.
Thank you, sir.
Thank you. Okay. Thank you. Okay. Thank you.
Thank you, sir, for the valuable time in sharing your expertise on ozone for fresh produce, quality and safety, framing the lecture on ozone introduction, their production sources, its essential features that characterize the ozone treatment, including the components of the ozone system. Sir also emphasized on the ozone measurement, working principle, its impact on microorganism in food products, cons and pros of ozonization in fruits and vegetables. Once again, thank you, sir. Now, I request all the participants to break for the lunch and assemble here by 1:45 p.m. for the next lecture. Thank you. 1:45 p.m.
Shall I start?
A warm good afternoon to one and all present here. Today we are going to start about our afternoon session, which is handled by Dr. Arun Prasath sir. Session is over to you, sir.
Thank you. Good afternoon to all. So, we have been discussing about various post-harvest operations from the beginning, right? There is one basic post-harvest operations which we commonly use in everyday activity. What is that? To extend the shelf life or to retain the quality of the food materials, especially fresh commodities. It may be a fruits and vegetable, or it may be fresh meat product, milk product, or any fresh commodities. We mostly rely on a efficient cold chain to maintain the quality and reduce spoilage of fresh agriculture commodity. So in this lecture, we will see some of the important aspects about the cold chain management activities, and then cold chain gadgets available to maintain the commodity under reduced temperature, and some of the softwares, cold chain related softwares available to enhance the safety, food safety and quality of the food materials. So in this content, we will discuss about importance of cold chain management, components of a cold chain, a physiology of a perishable product, and effect of cold chain on quality of the perishable commodities, cold chain gadgets, and the recent IoT and blockchain technology for cold chain. So in India, 1/3 of horticulture produce, especially fruits and vegetables, are wasted every year. As you all know, from the beginning, like even 10 years back, it was like 30%. Again, before even 20 years before, it was 30% to 40% of horticulture commodities. We are improving our facilities, especially cold chain facilities, infrastructure facilities related to agriculture commodity storage and distribution and supply chain. Still, we are facing a very big losses, a very big portion, 1/3 of a horticulture commodity which we produce is lost. India is already self-sufficient in agriculture practices. We are producing sufficient enough to feed the entire country. Moreover, we are producing surplus which we can export to other countries, especially fruits and vegetables, grains, meat and dairy products, fish and fish-based products. So million across the country suffers from malnutrition. Like even though we are producing sufficiently, still children in India are facing malnutrition. And you can see in 2020, the global hunger index score of India is 28.5 in 2020, and it has 15.2% undernourished population in India. So there are, we can say, so many things related to the malnutrition and nutritional malnourished children, and in unavailability of nutritious food for the Indian population. So the global cold chain logistic market is a very vast and valued at 159 billion in 2020, and it is expected to reach at 585 billion by 2026. So there is a very big investment coming into the infrastructure development. Like it may be construction of cold chain facilities. Like India, we are identifying the district level farmer producer group, and we are clustering them, and we are constructing cold chain facilities or any other facilities like packhouse facilities, which is required for area specific development. Area specific infrastructure developments are going on. That is why we can see there is a huge investment and there is a huge value of cold chain coming in India, and it is estimated an annual value loss of agri produce in 2022. If you see the data available from the 2022, nearly 92,000 crores of rupees is lost due to insufficient cold chain and insufficient post-harvest gadgets in our country. Out of this perishable product like fruits and vegetables, meat, fish and milk, which accounts an estimated loss of 50,000, almost 50,473 crores of rupees is lost, especially in case of fresh commodities, where the perishable commodities which have very low shelf life, and there is only way to minimize the post-harvest losses in case of perishable is immediately bringing them into a cold chain. Cold chain in the sense uninterrupted cold chain is recommended right from the harvest until it reaches the end consumer. So reducing the post-harvest food loss at least 15% from the current value of 30% could provide 18.3 million ton of fresh fruit each year, which is valued at 3.9 billion. Okay, so you can see cold chain sector, which holds the key for addressing this existing food loss problem in our country, directly by increasing the shelf life of the food and indirectly by reducing the reach of food to the market and processing facilities, right? Still, by establishing a well connected cold chain facilities, a particular crop, the value of particular crop can be increased double, or the farmer's income can be doubled. If you see a grapes which is selling in India for 80 rupees per kg, 80 rupees per kg, if it is exported to a Middle East country where we can get more than 250 rupees per kg, in such case cold chain holds the key in extending the shelf life, extending the market reach of a particular commodity. So what is cold chain? The cold chain is a temperature controlled supply chain. We have an existing supply chain for all the commodities in India, like we have onion. We have a very established supply chain for onion and potato, which are a staple food for Indians. More or less throughout the year, we try to maintain the price of the potato and onion in a similar range, right? So already there is a supply chain which exists, which involves a lot of middlemen, vendors, distributors, stockholders. So if the existing supply chain of a particular commodity is replaced with a temperature controlled system, in a temperature controlled supply chain, it is called as a cold chain system. Okay, so an unbroken cold chain is an uninterrupted series of refrigerated production, like storage, distribution. Once you harvest from the mother plant, it has to be immediately, the temperature of the commodity has to be reduced. All the field heat which is there within the commodity has to be removed first. That we call it as a pre-cooling process. So after cooling, it is transported to a pack house or a cold storage, and then in a refrigerated transport it is transported to a retail outlet, or through an air cargo or a ship cargo it is exported to other countries for retailing and distribution. So this kind of temperature controlled distribution system will help us in lowering the it helps us in distributing this temperature control system. It is used to preserve and extend and ensure the shelf life of the products such as fresh agriculture commodities, seafoods and frozen foods. So cold chain provide the following benefits for perishable food materials. It reduces the respiration. You know the metabolic rate of a commodity, agriculture commodities, reduces when you reduce the temperature of storage. Similarly, the cold chain reduces the respiration. Once the basic metabolic activity, respiration, is reduced, it reduces all other metabolic changes which is occurring within the commodity. And it reduces transpiration. It reduces the water loss. It reduces shrinkage of commodity, and then ethylene production. You know, the ethylene production is one of the end product of a metabolism which is taking place within the food materials. So once the ethylene production is minimized, it slow down the respiration. So the respiration rate and this ethylene activities are interdependent. When we address one respiration issue, again the respiration rate will also reduce the ethylene production, thereby the ripening is delayed. And then increase resistance to the ethylene action, decrease activity of microbial decay in case of fruits, and reduce browning and loss in texture, loss in flavor and other nutrients. Okay, so you can see field storage from the field, when it is harvested, when it is shipped, until it is reaching an end consumer or the end kitchen or the end user table, it has to be maintained under the low temperature. That is called the cold chain. The components of cold chain. If I ask you what are the components of cold chain, everyone will tell cold storage is in our country, we see the cold chain starts from the cold storage. Right, there is no other interventions available for reducing the temperature of the commodity, whereas the efficient cold chain begins from pre-cooling operation. Pre-cooling is one of the key which holds the key for enhancing the shelf life or extending the shelf life of a fresh commodity. So pre-cooling is nothing, it is removal of field heat. Immediately after harvesting, detaching the fruit from the mother plant, it remains at the higher temperature, like 28, 30 degrees Celsius. From 30 degrees Celsius, it has to be brought to a minimum safe storage temperature of 2 degrees Celsius or 4 degrees Celsius, depends upon the commodity. So pre-cooling is performed on the farm itself, that too within a short duration of time. Short duration of the time in the sense 3 hours to 4 hours. Within 2 hours to 3 hours, if you can able to reduce the metabolic activity, it initially reduces the respiration rate and it also reduces the ethylene production. But what we do in our condition, Indian condition, is we allow the commodity to respire. We store it under the open field itself. It increases the respiration rate and it increases the ethylene rate. Once the ethylene activity is increased, then it will be in a multiple fold. It is exponential increase. Right? One molecule of ethylene will trigger autocatalytic production of ethylene in the fruits and vegetables, and it is a exponential increase in growth. So once after ethylene production starts, if you are minimizing the temperature or if you are reducing the temperature, then there is no use. So it should be starts with the pre-cooling and then packing and cooling fresh food product. Like food processing, you can see freezing of certain processed food materials, and then cold storage. Cold storage, there are long-term cold storage, short-term cold storage, or you can see there are different types of cold storage for different types of commodity. We have cold chain for dried red chili. We have cold chain for a fresh apple. We have a cold chain for frozen foods. So the temperature which we maintain, the temperature and relative humidity conditions which we maintain differs from commodity to commodity. And then distribution, even during distribution, cold transport, temporary warehouse under temperature controlled conditions. Marketing, like refrigerated container, refrigerated display racks, refrigerated marketplace. So these are some of the component which helps us in maintaining the temperature of the commodity under low temperature. So first, as I said, pre-cooling, and then the pre-cooling which reduces the field temperature of a fresh horticulture commodity. The target temperature depends upon the type of commodity, and then our pack house facilities. In pack house we have various operations like sorting, grading, washing, drying, packing, even waxing, wax coating. So all those things are performed in pack house operations. In a modern pack house operations, it starts with pre-cooling and then grading, proper grading based on the ripening stage, and then some pre-treatment, pre-storage treatment like waxing are done in the pre-cooling in the pack house systems. And we have different types of pre-cooling systems. Small scale, in farm level we have mechanical pre-cooling technologies like portable forced air cooling systems, or packing with ice will also help us in reducing the field heat. And the non-mechanical type, we have a portable evaporative forced air cooling systems, and in large scale we have vacuum cooling, hydro cooling, forced air cooling system, forced air wall cooling systems. And then non-mechanical, when you pack with dip it in a ice slurry, will also help us in reducing the temperature immediately after harvest. So that is this where we have this, where we don't have these pre-cooling facilities. We recommend the farmers to harvest at the early morning. Like the fruits and vegetables, we recommend it to harvest at the early morning stage, because early morning temperatures will be lower. So if you harvest, the commodity will be under low temperature, or the refrigeration load required to reduce that field heat will be reduced. So current scenario in our country is there is no pre-cooling operations or on-farm storage operations. Immediately it is, after harvest, it is brought to a nearby market, or it is sold to a vendor where he procure in bulk and then he take it to a multi-commodity storage, where the temperature is not a product specific, it is a region specific, right? So principle of half cooling time. The literature says immediately after harvest, within 3 to 4 hours from harvest, the temperature of the commodity should be brought to like 7/8 cooling time, right? So initially if the product shows 25 degrees Celsius, the temperature has to reduce to below 5 degrees Celsius within 6 hours of time. Then the potentially the particular product, a particular batch of product will have a longer shelf life in the market. So the rate of cooling of produce is also one of the major factors which we have to look into when we are performing the cooling process. Like cooling a commodity is a heat and mass transfer operation. When you allow air, when you are forcing air to pass over the surface of the fruits and vegetables, what we are doing, we are reducing the temperature, and then the heat transfer occurring between this forced air and the product is conventional heat transfer. So what happens here, it doesn't alone reduce the temperature, it also remove moisture from that. So if you are keeping it for a longer period of time under a forced circulation, easily the product loses its weight. The transpiration occurs and easily the product gets shrink. So that is why we have to make a calculated temperature decrease in the product. So within a shorter period of time, we should be able to reduce the temperature to 7/8 cooling time. So that is a half cooling time. So half cooling time should be shorter to reduce or to avoid shrinkage in the commodities. So the rate of heat transfer depends upon the cooling medium. Mostly we rely on air cooling, or in some case we have hydro cooling. So the temperature of the air or the temperature of the water or the delta T, the temperature difference between the product and the temperature should be maintained in such a way that it reduces faster. The rate of cooling is faster. And then the difference, the temperature between the produce and the cooling time, the nature of cooling medium. Moist air will help us to retain the, arrest the transpiration problem or the water loss problem. Okay. So if the temperature, if it is a dry air, it tends to remove more moisture very quickly than the moist air. Now, cold chain logistic. In global market, the cold chain logistic play an important role in food safety and food waste. So the perishable food, including fresh fruits, vegetables, dairy product, meat and fish products, need to be maintained at a low temperature or under frozen state throughout the entire supply chain. So cold chain logistics provide facilities for transformation of processing and goods, as well as ensuring this safety and sanitized condition. So this farm to fork transportation is essential in case of frozen food materials. A vast global transportation network is required in it, which includes the manufacturer, supplier, warehouse, retailers and consumers. All means of transported should be brought under reduced temperature or under cold chain. So you can say the cold chain, you can see different types of cold chain. Frozen, minus 18 degrees Celsius, the frozen ingredients, processed foods, and then the fruits and vegetables, ice cream and frozen meats are transported under the reduced cold chain temperature of minus 18 degrees Celsius. This is frozen food cold chain temperature. Chilled cold chain, that is 0 to 10 degrees Celsius, most of the fresh commodities, right from fresh fruits, vegetables, fresh meat, milk, butter. Mild chilled cold chain, like 10 degrees Celsius to 20 degrees Celsius. Subtropical fruits. Subtropical fruits like we can say our onion, red chili, even tamarind is transported under reduced conditions. So there are so many other products which is coming under this mild chill cold chain, and normal cold chain is reduced less than 20 degrees Celsius. Whole onion, dehydrated food, pickle, jam, processed foods are transported under this about 20 degrees Celsius. Now, so far we have discussed about this what is this cold chain, what are the gadgets available for cold chain, and how the temperature is maintained under low temperature, what are the important cold chain operation will need to be addressed. Now we'll see some of the basic principles for increasing the shelf life of a perishable commodity. First of all, the fresh fruits and vegetable, what we are talking about, right? The fresh commodities, fresh fruit, vegetables, flower, or any other plant part is a living tissue that are subjected to continuous changes after harvest, right? Some of the changes are desirable, but most of them are not desirable changes, right? Ripening is a desirable changes. So once you harvest, if a fruit ripen after harvest, that's a desirable change that we can expect. Or when you are about to consume the fruit, it ripes on the way from harvested end to the end consumers. There are commodity which are harvested before ripening and it is ripened after harvest. For example, our banana, and we have our papaya, right? If it is papaya, if it is harvested at the complete ripened stage, transportation become very difficult. So in such case, we harvest it in a unripened state and we allow it to ripen during the transportation. So there are some of the desirable changes, but most of the changes are undesirable. The main goal of post-harvest cold chain, the main aim of post-harvest cold chain management is to slow down these changes, right? Or not only the cold chain, whatever post-harvest interventions you pinpoint, it will aim at minimizing the metabolic changes associated with the freshly harvested commodity. For example, we have wax coating. We aim reduced respiration, and we retain the freshness of the commodity. Or it may be an edible coating, or it may be a packing, or it may be any kind of post-harvest interventions. Most of the post-harvest interventions, we can see it aims as minimizing this metabolic changes after harvest. So after harvest, fruits and vegetables are detached from the mother plant and it do not enjoy any more supply of water or nutrients from the mother plant. Until it is detached from the mother plant, it has continuous supply of nutrients. Therefore, after harvest, the fruits and vegetables depends upon its own carbon reserve for respiration. So after harvest, the fruits and vegetable depends on its own carbon and water reserve, which makes this commodity more perishable. Okay, if the commodity respires higher, it is more perishable. It consumes its own reserve in a faster rate and it depletes itself. So they loses the water and dry matter content as the result of respiration and other metabolic activity. So fresh produce are derived in very diverse in case of morphological structure. There are root vegetables, there are some asparagus like stem, we consume the stem as a vegetable, leaf as a vegetable, flower as a vegetable, or fruits as a edible portion. So in composition or in morphological structure, morphological character, these portions, these particular fruits and vegetables differ. So if you see, therefore, the cold chain requirement is also vary among the commodity. For there are some frozen poultry and meat product where we need minus 25 degrees Celsius, or frozen foods minus 20 degrees Celsius. Dairy products 2 to 1.5 degrees Celsius. And then low temperature apple, strawberry, carrot, lettuce, where the respiration rate is lower, we can go for 0 to 2 degrees Celsius, or even 12 to 16 degrees Celsius. Right? It depends on the commodity, the nature of the commodity which we are about to store. So horticulture products can be classified according to their respiration rate. Low respiring, very low respiring, moderate respiring, high, very high and extremely high respiring commodity. If a particular commodity produce 5 to 10 milligram of CO2 per hour per kg at a temperature of 5 degrees Celsius, we can categorize under low respiring commodity, right? Very low is less than 5 milligram of CO2 per hour per kg at a temperature of 5 degrees Celsius. So you note that this temperature has a major role in determining the rate of respiration. If it is 5 degrees Celsius, means it is reduced to respiration. If it is 30 degrees Celsius, it will be higher, the rate of respiration will be higher. So you can see commodity, low respiring commodity, mostly you can see the dormant stage of fruits and vegetables, or storage portion, storage part, garlic, onion. So this comes under bulbs and tubers comes under this very low respiring. Moderate respiring, we have tropical fruits. High respiring, the commodities which are harvested in the active growth stage, sleek, lettuce, most of the leafy vegetables which is harvested in the active growth phase. And then we have extremely high respiring asparagus, mushroom, parsley, peas. So there are some of the extremely high respiring commodity. Now according to the respiration behavior, during maturation and ripening, fruits are classified either climatic and non-climatic. These climatic fruits shows a larger increase in the respiration and ethylene production during ripening. Okay, so this classification is very important for determining any post-harvest operations. Either it is climatic fruit or non-climatic fruit. In our condition, the thumb rule is, if it is a non-climatic fruit, we never bother about the post-harvest handling techniques. It as such, by itself, it takes care of its storage, and it stays in the market sufficient time. So we don't perform or we don't give any post-harvest interventions except packing and distributions. Whereas the climatic fruit, right, the climatic fruit is very difficult to extend the shelf life because it shows a larger increase in respiration and ethylene production after harvest. So after harvest, it enters into a autocatalytic production of ethylene, which makes it more perishable. Okay. So this is the difference between, I can explain more well using this particular graph, climatic and non-climatic fruit. So as I said, the respiration rate, CO2 production per kg per hour, right? So all the fruits, even it is, if it is a climatic fruit or non-climatic fruit, immediately after harvest, this is the point where it is detached from the mother plant. Okay, so it has a pre-climatic minimum, like pre-climatic declination. You can see it declines, the respiration rate declines both in climatic as well as in non-climatic. The only difference is after a certain period of time, like this particular declination is due to shock. When it is detached from the mother plant, it was continuously enjoying the water supply, nutrient supply from the mother plant. Suddenly it is detached from the mother plant. In a harvesting shock, will be a pre-climatic minimum, like the temperature reduces or the respiration rate reduces for a particular period of time. For example, you can see in our case, like mostly it is 4 to 8 hours. The 4 to 8 hours, it depends upon the commodity again. So this preclimatic minimum, the preclimatic declination continues as such in case of non-climatic fruits. It doesn't respire again. The respiration rate keeps on reducing in case of non-climatic fruit. You can see non-climatic fruit, the respiration rate keeps on decreasing, whereas the climatic fruit, it rises immediately after harvest sometimes, no, after 4 hours, let us assume after 4 hours, it rises to a climatic peak and then it declines after some time once it is completely matured, or we can say once it completely utilized all its metabolic reserve. There comes a post-climatic declination where the respiration rate decreases by itself. Now, the magnitude of respiration makes it high respiring, low respiring, moderate respiring within climatic fruit. So climatic fruit will have this curved metabolic rate, the curved respiration rate. You can see apple is stored for a longer time, right, without any without many post-harvest interventions. It is stored for 6 months just by reducing the temperature. But it is also a climatic fruit. You can see initially the respiration rate decreases and then the respiration rate increases. But the intensity or the magnitude of respiration matters. So the maximum respiration rate is less than 10 milligram of CO2 per kg per hour, whereas, or ml of CO2, here it is less than 10 ml of CO2 per kg per hour, whereas in case of banana, immediately there is a steady increase in respiration rate, and the respiration rate reaches more than 35 ml of CO2 per kg per hour. Still in avocado, it is even more. It reaches more than 60 ml of CO2 per kg per hour. So this intensity of respiration decides whether it can be stored longer in a market, or whether it requires a severe post-harvest interventions or it requires a less post-harvest interventions. So apple, if I see apple, only a small wax coating and in cold chain will help it store it for a year together, like throughout the year. Whereas whatever severe post-harvest interventions we give to banana, it cannot last more than 30 days, right? Similarly, avocado, whatever severe post-harvest interventions we go for coating, edible coating or wax coating, you reduce the temperature, you add ethylene blockers, you prevent it from contact of ethylene, still you cannot store it beyond 3 months. So that is the post-harvest interventions. The level of severity of post-harvest interventions required is based on the magnitude of respiration of the commodity. As I said, this is the changes associated with color changes associated with the climatic fruit. So when there is initially, you can see this is 10 milligram of CO2 per kg per hour. Initially it reduces, it is harvested from the mother plant, and you can see there is no respiration rate. Here it is respiration rate decreases, and then the respiration rate increases with respect to time, and you can see the associated color change. And once the metabolic reserves are completely utilized, we have a post-climatic declination. So this is climatic peak, and this is post-climatic declination, and this is climatic rise. This is climatic rise. Similarly, in case of tomato, in case of banana, you can see it will be remain green within 1 hour or within 1.5 hours. You can see it could turn green color to yellow color immediately. So this color change or this metabolic changes are very faster in case of tropical fruits. Here, this is another graph, an interesting graph where we can see all the series of changes taking place during ripening. So this is the point. Let us assume this is the point we are harvesting a green matured banana, green mature tomato. So that you can see the number of stages like 0 day harvesting, and first day, second day, third day, up to 8th day. So in 8th day it became from green mature green to ripened red. It became ripened red in 8 days. In between we have a breaker stage where the green color breaks into a pearl red color or pearl yellowish red color, and then turning stage, green turn into red color or pink color, and we have a light red and dark red, a ripened red stage. Now, as I said, the basic metabolic activity, respiration, ml of CO2 produced per kg per hour. So initially the respiration rate, there is no, when it is harvested, there is no much higher respiration rate, and when the climatic rise, you can see the maximum respiration rate, and then it declines. The ethylene production and then the respiration rate go hand in hand. When the respiration rate increases, the ethylene rate also increases. Okay, so this is one of the point we should note down. The respiration rate increases along with the ethylene production, vice versa. Ethylene in turn also triggers the respiration rate. And then we have total soluble solid contents, soluble solid concentration declining from harvest, and it is associated with the changes in the conversion of complex sugar, like conversion of starch into simple sugars. So the starch percentage is also declining. And then the color change. We know the chlorophyll pigment declines, or the chlorophyll content reduces and the lycopene content increases. You can see this is a turning, this particular turning stage, you can see it turns from green color, that is chlorophyll pigment, or you can say the lycopene pigment dominates the chlorophyll pigments in the turning stage. And we have firmness and our polyelectronic activity. So you can see the firmness decreases. Similarly, the polyelectronous activity, the enzymatic activity increases. It loosens the cell structure, or we can say it breaks down the molecules in the cell wall. It makes it more firm, from firm to soft. And then the pH and titratable acidity. The pH decrease initially during ripening, the pH decreases, and you can see the titratable acidity increases along with the pH. So these are the changes. These are the overall changes, overall biochemical changes take place when the fruits ripen from a green state to a red, mature red state. Okay. Now, the water loss. Another important post-harvest problem is water loss. Even when you are bringing it under the cold chain, if it is not maintained under a regular, if the humidity is not maintained under higher humid condition, it loses moisture. And as I said, during heat transfer between the forced air and the commodity, there exists a lot of transpiration or water loss. So water loss is the main cause of deterioration, because it results in direct weight loss, means it reduces. Direct weight loss means it is a loss to the seller or the farmer. Losses in appearance. We won't prefer, if it looks fresh, we prefer from market, right? If it is a shriveled or shrunken fruit, we won't prefer. And then the loss in textural quality. Most of the fresh commodities we consume for its softening and crispiness, like crunchiness. We can say the carrot, if the carrot loses its moisture, it becomes rubbery rather than crunchy. Similarly, the vegetables, sleek or asparagus, we consume for its crunchy biting nature. So if it loses its moisture, it loses its crunchiness. So water loss in case of shriveled apple, the only one post-harvest interventions which is performed very easily control this water loss for longer term cold storage. Apple and all, we store it under cold storage for 6 months, 8 months, even year. In such case, to avoid a faster rate of transpiration or faster moisture loss, we go for a wax coating. So wax coating prevent, even if it is stored under a year under a cold storage. When it is in a cold storage, the temperature is lower, metabolism is reduced, but the thing is, it is continuously under a current of movement of air. So the temperature drops, or the temperature reduces, force the air is circulated continuously. So to avoid shrinkage, it has to be wax coated. Ways to reduce the water loss after harvest, like lowering the temperature and then higher humidity. Along with the temperature, we have to check the humidity, and humidity holds the key for water loss. lower temperature, higher relative humidity, prevent surface injury. If there is a bruise or if there is a open area or open wound in the fruits, it accelerates the water loss. So prevent surface injury, application of wax or other coatings, wrapping with a plastic film. So these are some of the post-harvest interventions we recommend for water loss. So pomegranate, you can see the same variety of pomegranate, the gap. This is the initial stage. It shows a sound fruit. After few days, you can see the commodity shrinks. The nature of this pomegranate, you can see the water transpiration will be higher. If it is lined with a plastic bag, we can prevent this water loss. 50% there will be a water loss prevention. You can see the effect of wax and seal packing on weight loss of orange. This is a margarine orange. The first graph shows a control. So this is a control, and we have wax coated and this plastic lining or plastic sealing. So the number of days from up to 90 days or 90 days they have made a study, and you can see the weight loss in control. It reaches almost 80 to 20% of weight loss, 20% of weight loss in case of a control sample, whereas wax coated, you can see the weight loss is reduced. Wax coat along with the plastic lining, it reduces below 2%, or you can see almost only 2% of weight loss. So this kind of interventions can reduce water loss. And then now the next problem is physical damage. Physical damage such as due to mechanical harvesting or during transportation, surface injury or bruising, vibrational damage. So these are some of the main possibilities of physical damage in case of fresh commodities. And this is a main contribution for spoilage, microbial spoilage. When there is a physical damage, it easily starts with a microbial spoilage. The damaged area became brown, that is due to enzymatic activity or leakage of phenolic components from the fruits, and it accelerates the water loss from that bruised surface or damaged or injured surface. And again, ethylene production. When there is an injury, it triggers the ethylene production. It enhances the rate of ethylene production and then provide site for pathogen invasion. So the wounded area allows microbial infestation, and then again the healthy fruit doesn't spoil faster. The damaged fruit spoiled faster because it pays a infestation site. It allows infestation, easy infestation for a commodity. So you can see this is a compression bruise, impact bruise in case of apple and orange and cherries. So this particular spot paves a way for infestation, and the spoilage starts from the particular region. And then bruising and skin obsession in case of guava and banana. This is very common. We never get a banana without this brown spot because it is transported longer under road condition. If it is not properly cushioned or if there is no proper cushioning material, it leads to abrasion between one over another. It causes skin obsession. So guava is also a commodity which is often get bruised or skin obsession during transportation, and banana. And then we have physiological disorder which caused by improper storage condition, especially when you fail to maintain the temperature exactly towards the particular commodity. It causes chilling injury. In Indian condition, we have multi-commodity storage. We don't have a commodity specific cold storage. We have a common cold storage, and the cold storage person will charge you 10 rupees per kg for 6 months, right? Even if it is apple, we store it. Even if it is a cherry, even if it is a pineapple, we store all the commodities in a single storage. So it's a multi-commodity storage systems. When there is temperature is not specific towards a particular commodity, it leads to chilling injury, freezing injury, and then heat damage. Low humidity changes, low CO2 injury, and high CO2 injury. It's not only, when I say cold storage, it is not only that temperature and related humidity conditions. It is also the gas composition. Okay. So, tropical and subtropical fruits are sensitive to low and non-freezing temperature below 15 degrees Celsius. We never store banana in refrigerator, right? It is easy for banana to get chill injury. So the most common symptoms of chilling injury includes surface and internal browning. In banana, obviously, if you store your banana in refrigerator for 2 days, the third day if you make a cross section, the internal browning, you can see internal browning. Even in winter also it is common, but we never notice that we consume banana as such directly. We doesn't make a cross section of banana before eating, right? So we never notice that chilling injury. But if you make a cross section, definitely you will see a brown core in the banana. And then pitting, water soaked area, uneven ripening or failure to ripe. This is very common in banana. In winter, in severe winter, it fails to ripe. It remains hard, even papaya. Most of the tropical fruits, if the temperature is not sufficient, if the temperature is too cold, it doesn't ripe, it fails to ripe. Development of off flavor, and then it increases the decay rate. So these are some of the common chilling injuries in case of fruits. And these are some of the fruits and vegetables tolerant and sensitive to chilling injury. You can see the fruits chilling tolerant. Apple, it is chilling tolerant. Grapes, these things, most of the commodities are the fruits which is cultivated in elevated areas are chilling tolerant, whereas the tropical fruit, avocado, banana, mango, pineapple and sapota, these are some of the guava, jackfruit. These are some of the fruits which are very easy for chilling injury. Chilling injury in case of avocado, you can see the outer it turns black and inner also it turns into black color. In case of avocado, in case of orange, you can see this the burning of this skin. And chilling injury in case of yam and potato is also common. Chilling injury in sweet potato, you can see this water soaked area, water pitting. These are some of the examples for chilling injury in case of sweet potato. And in mango, you can see this rotting of surface near to the stalk. So that's kind of this is a example for chilling injury. In case of apple, you can see the core browning. So it's not ragi, it's a pear fruit. Sorry, peach. It's peach. You can see the chilling injury in case of this is fresh and this is chilling injury. Chilling injury in case of banana. As I said, now this is a chilling injury. In cross section, you can see that brown, the entire inner core became brown in case of banana when it is stored under refrigerated condition. And similar in case of pineapple, the core became brown. And in case of guava, you can see the chilling injuries, it gives a discoloration in case of surface. And freezing injury in case of orange. So orange, when it is stored for a longer period of time under cold storage, you can see this kind of fibrous fruit. The water gets evaporated, and then once it is freezed and then it get evaporated, it disturbs the cell structure and it aids water loss. Only we have a fibrous core. This is also a problem in case of freezing injury in case of orange. And then we have heat injury, the reverse of this chilling injury. If you are storing it in, you can see this kind of symptoms in case of most of the oranges available in market, because here we have an uninterrupted cold chain. So if it is stored for 6 months in a low temperature, immediately the vendor stack it outside in an open yard, it burns the surface. So this kind of heat injury is also very common in case of interrupted cold chain. So for only for one day there may be a power shutdown, or one day there may be a transportation failure, in the temperature maintaining device. So in such case you experience this kind of burn surface. So this is caused by exposure to direct sunlight or excessive high temperature. So symptoms like surface burning, uneven ripening and softening. Okay, so low humidity in the sense that is nothing, desiccation, water loss. So this kind of water loss, fibrous core are some of the examples for low humid conditions. Stored under low humidity conditions may enhance the disorders related to desiccation and water loss. And the last thing is pathological breakdown. As I said, when there is a bruised site or when there is an impact site, it paves a way for infestation. So it may be in any botrytis or expansum or rhizophyta, alternaria, phytophthora infestation. So these are some of the pathogenic infestation that are very common in case of post-harvest handling of fresh commodities, especially when you have interrupted cold chain or inefficient cold chain. Now, so these are some of the case study I have to show you the interesting results in extending the shelf life of a commodity. Let us see this effect of temperature and relative humidity in shelf life. In general, the food degradation process increases twofold with every 10-degree increase in the temperature. Okay, the food degradation or spoilage or rate of spoilage double with every 10-degree increase. Okay, a perishable food product with a recommended handling temperature of 0 degrees Celsius will have only 1/3 to 1/2 of its maximum shelf life if it is handled at 10 degrees Celsius. Okay, so if there is a 10-degree increase, it increases twofold the degradation process. In other words, you can say reducing the storage temperature 10 degrees Celsius will double the shelf life of a perishable. Every 10 degrees Celsius less reduction in the storage temperature will double the shelf life. So when the product is stored under 10 degrees Celsius, if the loss per day is 2 to 3% and the relative shelf life is 3 to 50%. If it is stored under 20 degrees Celsius, I am saying that if a particular commodity is recommended to store under 0 degrees Celsius, okay, 0 degrees Celsius, and if it has 100% shelf life, right, loss per day is less than 1%. If it is stored under 10 degrees Celsius, when it is recommended to store under 0 degrees Celsius, if the storage condition is 10 degrees Celsius, it makes 3% loss per day. We have to bear 3% of loss if you couldn't make it the temperature below 0 degrees Celsius. And again, 30 to 55% of shelf life, decrease in the shelf life. And if it is room temperature or above room temperature 40 or 30 degrees Celsius, the shelf life will be only 4 to 5%. The relative shelf life will be only 4 to 5%, and we can expect 20 to 25% of spoilage per day. So this is the relationship between the temperature and relative shelf life and the losses per day. And you can see the temperature and relative humidity of a particular commodity. You can see this is a mass loss of 3 peach cultivars. So the mass loss with respect to increased temperature and increased relative humidity, so lower relative humidity, which shows higher mass loss, and then the potential storage life will decrease of Brussels sprouts. You can see the Brussels sprouts decreases when the temperature increases from 5 to 20, 15 or 20, 25 degrees Celsius. Similarly, the asparagus and lettuce. In 0 degrees Celsius, it has 20 days shelf life. Again, in 5 degrees Celsius, it has less than 20. And in 15 degrees Celsius, it has only less than 10 days of shelf life. So temperature and relative humidity plays an important role, and this particular graph shows the marketability of the decrease in the marketability of strawberry, asparagus and raspberries with respect to delay in cooling. So how much time we delay before bringing into the cold chain. Strawberry, you can see if it is immediately cooled within 0 to 2 hours, it has a higher firmness and then it has higher marketability. And then if you delay cooling, instead of cooling it in 2 hours, if you are cooling it in 12 hours or 8 hours, you can see the marketability reduces from more than 90% to 40%. And the effect of storage condition, effect of storage on weight loss and storage life of pomegranate. So the same experiment which I shown before, no? The sample, fresh sample after 22 days. When it is stored under high relative humidity and low temperature conditions, it retains the critical parameters like weight loss is low, it reduces the color change, or it reduces the mass loss, and it retains the freshness after 22 days. Okay, the effect of, and then again another commodity, lychee. So this browning, this pericarp browning is very one of the major problem in case of lychee. In northern region of India, we produce large quantity of lychee, and if in southern part, it is very difficult to market to the southern part. We never get lychee, fresh lychee in market because of this pericarp browning. Within 2 days or 3 days, the pericarp turn from red color to brown color. So one of the key to maintain the color is humidification. If it is humidified or if it is stored under high humid or foggy environment, we need to use an atomizer that produce droplets like fine droplets of water, or you can see mist, a dry clouds like a dry cloud, which resulted in no depositing of water over on the fruit surface, but the relative humidity will be reaching higher, more than 95%, and the temperature maintaining and below 4 degrees Celsius, which it shows very good results. You can see even after 25 days of storage under 95% relative humidity and 4 degrees Celsius, the pericarp color is maintained. Whereas in case of control, you can see it is completely brown or it completely spoiled. And then another important parameters which we have to look into when we are talking about this color change in case of commodity is the water holding capacity of the tissue. If the water holding capacity of the tissue, if the moisture loss occurs or if the water loss occurs, it leads to enzymatic changes or it leads to cell damage. Once the cell structure damaged or the cell integrity damaged, it leads to leaking of phenolic component, and then the color change occurs. So this cell integrity or maintaining the cell integrity is possible, cell structure is possible only under high humid condition. So this browning is due to breakdown of cellular component. Moisture is important for maintenance of the cell structure of lychee. High humidity, we maintain the cell structure of the lychee. The weight loss is higher in control sample, which leads to loss of membrane integrity. So this membrane, once the membrane integrity is lost, it leads to phenolic ooze out of phenolic component, and the pericarp turns brown in color. However, only slight weight loss is occurred in case of commodity stored under humidified condition. Okay, and this is another results which shows the effect of pre-cooling treatment on respiration rate of grapes. So you can see the respiration rate of grapes remains under low rate when it is immediately pre-cooled, and this is the treatment, like pre-cooled immediately after harvest, and then the last one is pre-cooled or directly brought to cold storage after 12 hours of harvest. So you can see the difference in these treatments. So immediately if it is cooled within the 4 hours, you can see the one of the important problem associated with this green grapes is turning off this vein into this green color vein to brown. So the freshness of the grapes we can identify only with this vein color. If it remains green, it is immediately harvested, or it is harvested fresh. Within 4-5 days, this particular vein discoloration starts. So to avoid this vein discoloration, pre-cooling and low temperature, high humidity storage is recommended. So without harvest, like even during 40th day of storage, you can see it is completely spoiled if it is immediately bought, if it is bought directly to the cold storage without pre-cooling after 12 hours. Means within that 12 hours of time, the ethylene production would have started, right? And then it is of no use even bringing the lower temperature, still the metabolic activity continues in the slower rate. Okay. And then effect of pre-cooling in case of lettuce, you can see the respiration rate remains lower for 20 days if it is harvested. So only there is a small increase in the respiration rate. Okay. So this is the lettuce. You can see comparison of different pre-cooled lettuce. 20 days, even 20 days of storage, the lettuce, the leafy lettuce, which turns only the first few layers are color changes, like remains it's fresh, whereas it's completely spoiled in case of without pre-cooling or without pre-cooling if it is stored under refrigeration. So you can see this kind of water loss and the shrinkage occurs faster when there is no pre-cooling or proper cold chain is maintained. So spoilage of lettuce after 20th days of storage reaches 98.6%, means it is completely spoiled. 98.6% spoiled means completely spoiled, whereas the sample pre-cooled has only 10.3% spoilage. The next thing is cold chain management gadgets. I will try to finish it faster. So there are some cold chain management gadgets from harvesting. During harvesting, we have, as I said, pre-coolers, forced air pre-cooling, hydro pre-cooling systems, and we have food processing plant or pack houses, some of the cold chain gadgets required at the harvesting site. During transportation, we have refrigerated trucks, refrigerated cargoes, insulated shipping containers, cold storage facilities. In retail shops, we have display cabinets, beverage and this closed open refrigerated racks. And in consumer side, we have freezers, refrigerators, high performance coolers. And commercially, we have walk-in cold room or cold storage, refrigerated cabinets. These are some of the cold chain gadgets which connects different operations in a cold chain. So these are freezers, display cabinets, and visibility coolers. And this is another interesting study which shows conversion of these domestic air conditioners into cold storage rooms. So cold bolt is a technology which makes some changes in the refrigerant cycle, or it allows it makes some changes in the expansion valve. When you changes the expansion valve, the rate of cooling or the cooling load in a air conditioning system can be varied, and it can also be used for cold storage, domestic cold storage. You can see in a field study, it shows 6 metric tons capacity of farm level cold storage reduces 30% losses to 5% losses. You can imagine the quantity of product they have saved. From 30%, the losses is reduced to 5%. So these are some of the advanced reefer containers available in the markets for shipping fresh commodities across the globe. It has a refrigeration system to maintain the temperature and a humidification system, as well as it has gas sensors. So it continuously monitors the gas level inside, and it send signals to the receivers, to the company people, or else it makes corrective actions by automatic decision. It flush gas inside the chamber, it reduces the temperature, it flush, it automatically switch on or switch off the humidification system. So this kind of advanced reefer containers are now available for transportation of fresh commodities with gas sensors, with temperature, related humidity sensors and actuators. And this is one of the Indian startup. Threshold. This is one of the plug chill mechanism. So in this reefer container, we need a separate dedicated refrigeration unit. So there should be a refrigeration cycle, and the refrigeration cycle should run continuously to maintain the temperature. Whereas this is for domestic market or domestic supply. It has a thermofluid. It has a circulation of thermofluid. The temperature of the fluid is reduced initially by plugging. When the vehicle is standing in the night time, if it is plugged to electric current, it has a refrigeration system, it operates the refrigeration system, and it reduces the temperature of the thermofluid. And then during daytime, if the plug is removed, the temperature can be maintained for more than 5 hours and 24 hours temperature stability. If the temperature is stayed for 24 hours, the low temperature is maintained. So this kind of plug chill mechanism, which has 60% lower operation cost. Right. So these are some of other kind of alternatives for refrigerated vehicles or reefer containers. Now, new technologies in cold chain management systems for perishable commodities. As I said, this warehouse software management systems, where it collects data from each and every point of the warehouse operation, and it store it with the help of IoT device and blockchain technology. The informations are secured and the corrective actions are decided by itself, by AI. The corrective actions are decided, and the food traceability system. This is also coming up with blockchain technology. Each and every stage of harvesting and distribution site, the data are collected and secured with the blockchain technology, which ensures the complete traceability of the fresh commodity. Thermochromic ink, which shows the temperature and relative humidity conditions where it is stored during the transportation. And photocatalytic dye, which is UV assisted photocatalytic dye degradation techniques, which shows whether it is stored in an open yard or an open shipping yard. So this kind of photochromatic ink and thermochromatic inks helps us to trace the temperature history the products came across. And we have modified atmospheric packaging, you may be knowing all those things. Dynamic racking system with help of AML, dynamic racking. Which commodity comes first in a warehouse, which commodity should go first out for retailing, right? And then portable CA tent. So this kind of reefer containers, or within the reefer containers, portable CA controlled atmospheric conditions can also help us in increasing the quality of the commodities. And then multi-modal transport and PLC automation systems, ensuring the safety of temperature and humidity conditions. Alternate cooling. Apart from this refrigeration system, vapor compression refrigeration system, we can go for vapor absorption refrigeration system, and then magnetic leviation refrigeration systems. So thermal banks. So these are some of the concepts which is growing on recently in alternating the alternate cooling solutions for the fresh commodity, and various hybrid applications of energy sourcing. Solar based energy, thermal based energy, wind energy from ship during transportation, energy from the ocean itself. So there are some of the alternate energy concepts also coming into the cold chain management. Now IoT and blockchain technology for cold chain. So the use of Internet of Things in cold chain, already we have sensors, temperature sensors, humidity sensors, gas sensors, and we have actuators which can receive the signals from various sensors, wireless communication devices which shows from remote place we can operate what is the condition of temperature, what is the condition of the gas composition inside a particular silo or a particular reefer container. So all those things are already in market, and there are some softwares. So these wireless sensors, right from the farm till transportation, in distribution, in supermarket, RFID tag, it may be an RFID tag or a barcode sensor, or it may be any kind of gas sensor with wireless networking. Gas sensor, temperature sensor, pH sensor, which is connected to a wireless networking device. So whatever data we are sensing, and then the data will be collected, and it is secured to a data secure system, and then it is made available whenever it is necessary. That kind of blockchain technology with the help of IoT devices are coming up. Temperature monitoring during the entire transportation, shipping tracking, increased efficiency and productivity in case of logistics, reduced operational cost, reduced in spoilage of goods, real-time data, we have access to the real-time quality parameters of transported commodity, real-time data, access, automated report generation. So these are some of the plus points in case of blockchain technology. So farmers, they can have a data. Producers or a processor, they will have a data which they require. Distributor, retailer and end consumer will have access to all the data. Whatever data which is fed into this blockchain, they will have a secure data which shows from which animal the milk is taken, or from which tree the fruit is taken, and what is the condition of the tree right now. When you are consuming, we will have a data about the tree from where it is grown and what is the condition of the tree now. So in such a level, these traceabilities are possible with the help of blockchain, and these are the advantages: the transparency, tamper-proof, cost-efficient, and then the advantage and limitation of this blockchain technology, and this holistic collection of storage of data and information. This Emerson company provide software solutions where we can feed data during harvesting, processing, transportation and distribution, and it will be made available in a cloud storage. It can be accessible by any end users at any period of time. Listed, this is also another company which provides the software solutions, right from smart farming, semi-automated farming, traditional farming. What are the farming practices? The data related to the farming practices, data related to the pesticide given, data related to the irrigation, when it is irrigated, when the pesticide is given, when the pre-harvest spray, when the post-harvest spray is given to the particular crop. Right from there, tracking the cold chain, from how many days it is transported, how many under what temperature it is transported, and then the traceability of the cold chain connected to distribution centers. So all those things is possible. By end consumer can analyze all the data, can have access to all the data in this kind of blockchain supported supply system. So this is Source Trace. So this is one of the company which provide tracing solutions to the agriculture commodity, especially in case of minimizing this aflatoxin problem or pesticide related problems. The Source Trace has lot of advantage and lot of data collection point and data reliable points. So remote cold supply chain management. So from a remote place, a company, an exporter can have a look on his product, its quality, its storage temperature, whether it is ripened, whether it is half ripened, whether it requires any interventions. So all those things can be decided from a remote places. That is what the modern cold chain systems are approaching. So as I said, this Emerson and SenseMate. SenseMate is also another software solutions which provides end-to-end data collections and distribution sites. Okay. Thank you. Please, the floor is open for discussion.
Thank you, sir, for providing valuable content on the cold chain management of perishable foods, indicating the importance of cold chain management, benefits of cold chain management for perishable foods, components of the cold chain management, including its principle, describing the half cooling time. Sir has provided his expertise over the basic principle for increasing the shelf life of the perishable foods with the case studies. Once again, thank you, sir. Now, I request all the participants to move ahead for the demonstration. Student coordinator will escort to the venue. After demonstration, participants can disperse to the respective halls. Thank you.
know me now. So first I would like to tell you why packaging is important. As now we know in the market, every food product need a good packaging for the transportation, for the carrying, to extend the shelf life, and etc. etc. But here we are, what we are doing, we are using agriculture byproduct, food waste or meat byproducts, and from that byproduct or waste we are extracting biopolymers, and we are generating biopolymeric films that is biodegradable, edible, and having multidisciplinary actions in the food. Okay, so but what's the problem with the plastic films? For example, if I ask you, can anyone answer what's the problem with plastic? We are already having a very good barrier properties. Plastic packaging is very cheap and it's having good barrier properties. So what's the problem? The problem is that's the major concern. Okay, so this is the major concern because like in India, every year annually, like we are producing 9.4 million metric ton of plastic waste every year. That is like in the whole world is the second after China. Okay, so we are producing that much plastic, and in this whole plastic waste, this food packaging sector is contributing 43%. That is like around half of the plastic waste is generated by food packaging sectors. Okay, and after this what the introduction of this online, now if you see like why we are fighting here with this plastic what to say, packaging. Okay, so at the same time what we are doing, food industries are generating a lot of waste that we say sometimes green waste or red waste. Okay, it's coming from meat industry, so it's it can get spoiled, and it is it's give very favorable condition to microbes to grow, and that may harm our health also, because our health or animals who are roaming in this in the outside. Okay, so we are protecting that also, because we are reducing that waste also, and at the same time we are reducing the plastic waste too. So what we are doing in our lab, our group basically works on from the agriculture byproduct and as well as from the animal byproducts. For example, we are using seeds or straws, the rice straws, and different biopolymers from this chitosan from the shrimp cell, crab cell, and gelatin from fish, and from pork skin. A lot of like from meat byproducts. Like generally you see, if you go to the chicken shop, they throw their skin, they throw the feathers, which is having a very good source of protein. Like you can take out this gelatin or keratin, and this type of like legs also they throw. And at the same time, you see that in the jackfruit, most of the places people eat this jackfruit seed, but here people in some places they don't eat, they throw it. And tamarind seed, they throw it. A lot of like almost like all the fruits, people are throwing the seeds, which is having a good biopolymers in it. So what we are doing, we are extracting the biopolymers from those seeds and agricultural waste, you can say, or animal waste, and from those biopolymer we are making films. Okay, so now I will start how we are doing it actually. So for that, first of all, we need to extract biopolymer, that I already told you. For that can be done with some chemical methods. That's very simple. You can find it in lot of literatures. And after that, how we are doing that, how we'll make that a film. So basically, for example, here, for example, I'm taking here, this is gelatin. Okay, these are all the biopolymers, whatever we have now. For like, this is casein, and this is chitosan lactate, this is gelatin, this is starch, and this is gum tragacanth. Okay, and here also we have some synthetic biopolymers like polyvinyl alcohol, and this one is our pectin. Okay, like there are a lot of types of biopolymers available in the market, or you can extract by yourself also. And for that, after that, like we need one more thing, either plasticizer or cross linkers. What is a plasticizer? It provides the mobility to chains, polymeric chains inside the matrix, so that your films should be flexible. It's not like you don't need it like a papad. Okay, it should be flexible at the same time. At the same time, it should have good tensile strength. It should not be tear apart very easily. At the same time, it should not be like very rigid. It should be having some extensibility, flexibility, and it should be like easy to handle. It should not get teared up easily. Okay, and After that, we are the cross linkers are like a lot of types like sorbitol. You can use citric acid. We have, but I'm not showing it because of less space. And these are to bind the matrix to one polymer chain to with another biopolymer chains, or with the same type of biopolymeric chains to each other. Okay. And one more thing which is lacking this plastic packaging, it doesn't have any activity. Okay, it's not antimicrobial. If you pack a meat in a bag of plastic, you cannot say that it will prevent the microbial growth also. The microbes will grow, okay, because it does not have any antimicrobial property and antioxidant property. So for that, what we are doing, we can use like essential oils, like for example carboprol, apple seed carrier oil, and basil seed oil, spearmint or curcumin. And there are a lot of essential oils or bacterial compounds you can use. You can make pH sensitive films also, ammonia sensitive films also. You can make smart packaging also. So for an example, I'm going to demonstrate how we are doing it. So what we are doing is the solution casting method. So there are a lot of methods like compression molding and extrusion method, but here we are doing solution casting method. So for that, for example, I'm here taking, I've already weighted it, it's 3 gram, okay, 3 gram of gelatin. I have taken gelatin as a biopolymer, okay. So take beaker, I'm gonna take some water, distilled water or deionized water, whatever you want to take, okay. This is deionized water, and we are saying that we will take 3% of biopolymers. So we have to take like 97 gram of water. So I'm not going to weight it. I will just take 97 ml of water. Will pour this water in a beaker, and I will keep it on magnetic stirrer, and I will turn on the RPM. Okay, now it will rotate the solution. Magnetic bead will rotate the solution. Now first I'm not going to show this like waiting period, because first we need it to get heated at the temperature, like for example I'm setting 70 degrees Celsius. So that also varies from polymer to polymer. It depends on polymer, what the RPM you are taking, what the temperature you are taking. For example, I'm taking this gelatin. So sometimes we need to do hydrolyzation of the biopolymers. And in that case, what we do, we just put this biopolymer in water before putting on magnetic stirrer. After that, after half hour, we keep it on a magnetic stirrer, and then we heat it. But in this case, we don't need it. Okay, so why I'm keeping 70 degree? Because it's a protein, and the protein denaturation temperature is around 80 degree. So if I'm keeping the protein here, and if the 80 degrees Celsius reaches here, so protein will get denatured. Sometimes it's useful, sometimes it's not. So you have to check that also. It's not like you can take randomly some gram of biopolymer and you can do it. You have to optimize it. You have to do it 30-40 times. You have to spend months to get an optimized formulation. Okay, so for example, this is now heated for 70 degree on 70 degree, and it's rotating on around 500 RPM. Okay, now I will add the biopolymer slowly. Why? Because if I'll directly pour this whole biopolymer, it may form lumps. Okay, you can put it like this, or you can slowly slide it down like this, so that the whole biopolymer get mixed uniformly. Okay. Now, when you are working with any novel polymer, for example, that which is having very limited research, very limited literature, and you are not having too much data about it, so you may not be very sure that this plasticizer or this cross-linker is the best for that. So, for example, I am using glycerol here as a plasticizer, because I already know that the gelatin is able to form the cross-linking within the matrix. So I just want, but gelatin, because I'm working on the gelatin, so I know that the gelatin is very rigid and it's having very good tensile strength, but it's very less flexible. To then what I have to do, I have to increase the mobility in the chain, polymeric chains. So I need to add some plasticizer. So I already weighted. See, it's a 30% of the weight of the biopolymer I have taken. For example, 3 gram I have taken, so 30% of 3 gram weight. Okay. So that also you have to optimize. How we will decide that it's 30%. You have to check with like 20%, 30%, 40%, 50%. Then from that you do the mechanical testing, barrier testing, and physical testing. Then from that you select which percentage is giving the best film. Then you have to select that percentage only. For example, after heating it, it's getting mixed. I'm not showing because it's next batch is also there. So after it's got heated up to 70 degrees Celsius for like half hour, then after half hour I will add this glycerol here. Then I will cover it using this petri dish, and after that we have to just wait for another 10 minutes. Then we have to cool it down before pouring the solution. For example, sorry. So we have to cool it down. Then only we will pour on the petri dishes, and that too we have to weigh the biopolymer we are pouring on it. Okay. For example, I generally pour 20 grams because I am getting very good film on that, thin and having good mechanical properties. Okay. So you can pour 25 grams, 18 grams, or 30 grams depending on your biopolymers. Okay. So for example, now since we are already prepared one solution to show you. Solution. You can see this is very viscous. Okay. So for that, like, we start the characterization of the film from this stage. Okay. First we do the rheology of this, in which we see this viscosity, shear stress of the solution. Then we see the viscoelastic property, G prime and G double prime, in this like we say it frequency sweep test in this rheometer. Okay. And after that, how we do it, generally we put it in weighing balance and we tear it. Then we pour it slowly and let it spread by itself. Okay. Generally in 20 grams or 25 grams, the whole plate will be covered. And after this, we will just keep this one in hot air oven, and that one also we have to set what temperature we want to dry and for what time. For example, we are drying in 45 degrees Celsius for 1 day, sometimes 12 hours, sometimes even 48 hours. So after drying, after 24 hours or 48 hours, whatever you are drying, you will get the films. Like, for example, this. And if you are pouring the solution in big petri dish, you have to make last volume of the solution. And after that, if you pour in the same ratio, for example, area to volume ratio, same ratio, so you will get visible. Okay. So that's how you can make the films. This film is made from the xyloglucan, that tamarind, what you say in your language, we say imli, that the seed of that tamarind. From that we have extracted the one biopolymer called xyloglucan, and that is only from that xyloglucan with glycerol, nothing else. So that's how you can prepare the film. Now, and after that you can do all the characterization like FTIR, XRD, DSC, mechanical testing, tensile strength, barrier property, water vapor barrier property, oxygen transmission, etc., UV barrier. Okay, so that's all about the film. Now I will show you how we're doing the coating. Okay, I will just put it back here. Go for the spraying method, that can come easily out of the nozzle. And if it's very viscous, you have to go with this dipping method only. So for example, I am taking this tomato. This is nothing, just dipping and taking out, so that you have to make sure that the whole area is dipped. Whole area of this tomato is dipped inside this biopolymeric solution. Okay. Now I can leave it here. Now, like after an hour, you will see it will become very shiny, and it will have a film covered the tomato, covering the tomato. That will increase the shelf life because it will reduce the permeation of microbes, and if you will remove the permeation of oxygen, that will increase its maturity, so it will be fresh for longer time. Okay, and sometimes to prevent it more further, we use the essential oils, which is having antimicrobial property. So if its surface is having some antimicrobes or environment is having some antimicrobe, that coating will not allow that microbes to grow inside and penetrate inside. Okay, so that will also increase the shelf life. And second one is wrapping. Once you can dip it inside this, and I can keep it like this only. Similar way, there's nothing very much to explain. Okay, for this one, sometimes it gets sealed with this hot sealing machine, sometimes it does. Temperature, it's getting sealed more better. Like this. Okay, so it's very evident that it can be sealed in this one, and it can be wrapped. So is this the cost? Like generally this cost of this LDP or LLDP is around less than $1 per kg, but for the biopolymer it goes up to $7. To reducing the cost is the biggest challenge, because this plastic packaging industry is already having very advanced setups, and it's very large scale industrial this setups also. So they are producing a lot, that's why it's very cheap, and this raw material is also very cheap. And but it's already evolving, the biopolymers. Maybe in future, very near future, it will get evolved, and advanced machines will come, and it will get automatically cheaper. And second one is the awareness. People should be aware that is also very big issue. So if anyone have any question, that's all about this. And if anybody have a question, so you can ask now, right now. Yeah, that question always comes, because I'm doing PhD only. So that question always comes. But so basically, like, it's the question of personal belief, ethics, and it's what to say, personal choice also. So even though some people who are eating who are veg, but they don't care about the packaging. Okay, but in India nowadays, if you see, most of people are non-veg only. So we cannot concern with this minority for the application of majority. If you see in the whole world, the non-vegetarians are in the majority. So why should we concern about that? It's already a very big market. So if it's reducing more than half of the plastics, so why not? So whoever want to prefer, they can prefer. And in any case, like gelatin, it's not only gelatin. There are a lot of, like, you see that one is there, Dr. Janaswamy. He's in University of which? South Dakota. He's making very good films, just like these films, from the rice straw and rice husk, from this agriculture waste, from the farms, and he's making very good films. That is acceptable for vegetarians or non-vegetarians. So we are doing our best from our end. They are doing their best from their ends. It's like. I have not done. It gets sticky. That also you can like counter it with your formulation. For example, if it is getting in like in different RH, for higher RH, like above head 60%. So you have to play with your plasticizers. If you are using glycerol, you try some other like plasticizer or cross linkers that can counter this issue. So because I have done like the same issue I was also facing at the beginning of my PhD. But later I reduced the concentration of glycerol, it got sorted out. I used the like PEG, citric acid, and this what sorbitol, but the glycerol reduction of glycerol was enough for me. So, in the case of coating, yes. So like that's why it's recommended like if you are getting coated like fruits, however it is edible, but still you should for your personal like sensory like appetite, you should wash it prior to eat. So yeah, migration is also very big issue, like migration of nanoparticles and migration of essential oils, and that is hampering this sensory analysis. That is also very big issue. That like in the case of wrapping, it's okay, still okay, but in case of this coating, it cannot be avoided 100%. So that will be always be issue. That's in that case you can do like for example, I am doing in chicken. So what I have done, like I'm using curcumin, that is coming from turmeric, but most of the people are using turmeric for the marination of chicken. So that's not that much like questionable. So that thing we can do, like whatever go with this food that we should use. Smell will be there. Yeah, it can matter. Yeah, those are the challenges only that still exist. Oxygen OTR I haven't performed because we don't have the facility here. So I'm not sure. I cannot say with the certainty that this is the permeability because we don't have the facility. So any other questions? Yes, tamarind kernel seed. Kernel. Yeah. Yeah. Okay. No, no. Yeah, it is totally soluble in water because that's why we are using water only, so that it can be removed later easily with water. Yeah, yeah. It doesn't need hot water. Normal temperature. For example, like if you want to test it, for example, I'm pouring this solution in petri dish and drying it, okay, and after that it's formed film. Uh, Instead of peeling it, I just pour some cold water. After some time, you will see that film automatically came out because it's hydrophilic anyway. That's the major challenge, because if you want to make something biodegradable, that must be hydrophilic also. That's why plastic is not biodegradable. That's very hydrophobic. Oxo, no, we haven't performed. We haven't performed. We are just doing this soil burial method. That's a disintegration of the film, not degradation. Disintegration we are doing only. Cannot save. Like piercing, it cannot save that much. If you have to do like coating twice, then only it will give some significant effect. Otherwise, it will only save the bruising, and that in transportation, like for example, in transportation with cases is going. So there are some like bumps is coming, so it will save the bruising and it will reduce this damages, like getting softened in the one end and not hard in the other end. So, more questions?